Hello.
Hello, yes, sir.
Yes, sir.
Yeah, Anup.
Yes, sir.
Can you listen me?
Yes, sir, yes, sir, yes, sir. Your voice is coming properly.
Voice is okay? Okay, I'll
Hello?
just try.
Yes, sir.
Hello.
Sir, better you have to on your video also. For
Okay. Okay. Just a minute. See, is it okay?
no, it's not coming, sir.
Still, it is not coming.
Yeah, it's no, not
I
coming, sir. Yeah, now coming.
I
Yeah,
can see. I can see
yeah.
myself.
Yeah. It's okay.
Okay. And should I try the sharings of screen as well?
Yeah.
So that we can have at least confidence.
Yeah.
Just
Because below down arrow is there. Share. Sir, during the introduction, you have to switch on your video. After that, you can switch off.
is it visible?
Yeah, it's loading, sir. It's loading. Yeah, PPT is loading.
No.
Still, it is showing loading. Yeah, I think no. Again, sir. Again, you have to share it.
No, yes. Just a minute.
I think internet connection is poor.
At my end.
Yeah, sir.
Speed test. Just okay. Let me.
Yes, sir. It's visible.
Yeah,
Screen is
not.
visible.
Yeah, now it's coming, sir.
Now it's coming. Okay.
Yeah.
Is it moving? Moving as well
Full
as?
screen. Yeah. It's moving. Yeah, now perfect,
Okay.
sir.
My voice is okay.
Yeah. Voice is okay.
Okay.
Okay. Yeah. Yes, sir.
Good afternoon, all, and welcome everyone for the third day of our 3-day training program, Advanced Outcome in Disaster Management and Risk Assessment by National Institute of Disaster Management and Manipal School of Architecture and Planning, Manipal Academy of Higher Education, Kerala. So it gives me immense pleasure and honor to introduce our first speaker, Dr. Manish K. Nima, who will be addressing a session on artificial neural network techniques for streamflow forecasting, theory and application. Dr. Nima is a water resources engineer and currently serving as a scientist in the Water Resources Systems Division of National Institute of Hydrology, Roorkee, Uttarakhand. He has a rich experience of 15 years plus in R&D with a specialization in water resources. He has also handled various other technical and administrative responsibilities independently. He is leading the function as an officer in charge of remote sensing and GIS. In his previous assignment, he served as scientist in charge of Western Himalayan Region Center of NIH at Jammu. An engineering graduate in BTech from Jawaharlal Nehru Krishi Vishwavidyalaya from Jabalpur, a postgraduate in MTech from GB Pant University of Agriculture and Technology, Pantnagar, and has been awarded a PhD from Indian Institute of Technology, Roorkee. His area of expertise is hydrologic modeling, focusing on impact studies of climate change, experimental hydrology, estimation of evapotranspiration, water audits, application of advanced tools such as artificial neural networks, remote sensing, GIS, etc. Right from his school days, he has been recognized and rewarded various scholarships from the Grameen Pratibha Scholarship from 6th to 8th standard, National Scholarship from 9th to 12th standard, and during his college days, MHRD Fellowship by the Government of India for Postgraduation Studies. He is a Best Paper awardee for 2 of his papers presented at international conferences, and he is a member of the editorial board of NIH's Hindi technical magazine Jal Chetan and a reviewer for various journals and magazines. His areas of professional consultancy include water availability studies, carrying capacity studies, power potential studies, etc. He is a life member of a few professional water societies like IAH, ISRS, SCSI, etc. He has been involved in more than 20 consultancies and sponsored research projects, guided 5 MTech theses, published more than 45 papers in peer-reviewed international and national journals, and international and international conferences, and 10 technical reports. Dr. Nima has published more than 18 technical articles in Hindi. He has organized 7 training courses for the researchers, faculty members, and water resources practicing engineers. Dr. Nima visited the United Kingdom and Indonesia for scientific works. I would like to invite Dr. Nima to start the session.
Thank you, Rakshit. Thank you very much for nice introduction. Okay, so I just try to share my screen. Is my screen is visible to you?
Yes, sir.
Yes, sir. It's visible.
Okay, thank you. Thank you for the confirmation. Yeah. So good afternoon to all the participants, and thank you to NIDM as well as Manipal Academy of Higher Education for giving me this opportunity to share my thoughts on the very pertinent topic, that is on the advanced soft computing techniques in disaster management and the risk assessment. So, as introduced by Rakshit, that I am from the National Institute of Hydrology. So basically, it's a research organization of Ministry of Water Resources. So we usually work in the field of hydrology, anything pertaining to water research that we deals with. So we have variety of expertise in our institute, right from the surface water, groundwater, and water quality prospects. And I am from the division called Water Resource Systems Division, wherein we deal with the system problems such as the reservoir operations or the designing of the various water resource projects, planning, and other things. And artificial intelligence nowadays becoming a boom, and it is being, you know, implemented or being applied in all the respective fields, and hydrology is not an exception. So we are also doing some work in the hydrological field. So in this talk, we will be seeing how this artificial neural network, which is a part of the soft computing technique, its application in the stream flow forecasting. So we will be try to touch upon what are the different theories and what are the various steps and the stages involved in applying this ANN into a stream flow forecasting. So this is a very basic slide about the stream flow. So most of you may be aware that whenever we have a river or a stream, so it what is the amount of flow at a particular section, that amount of flow or water is called the stream flow, right? And stream flow is a very complex process in nature, as well as it is non-linear, and it is being affected by many factors such as the catchment characteristics. So I believe that everybody is well aware of what is a catchment. So catchment is a drainage area wherein all the water received in that particular area is getting out out of that area from a single point, and that area is called the catchment area. So the stream flow depends on the various catchment characteristics, like see what is the slope of the catchment, what is the land use land cover present in the catchment, that governs the stream flow. What are the storm characteristics? Like storm characteristics here, I mean that what was the intensity of the rainfall? Basically, rainfall is the sole source of the water in the rivers or in the streams. So that primarily governs the stream flow. There are other geomorphological characteristics and other climatic characteristics. They also affect the stream flow. So why this stream forecasting? Why we are interested in stream forecasting? Basically, it is very much required for three purposes. First is the designing, planning, and maintenance of any hydraulic structures. And the major hydraulic structures we are dealing with in India is the dams or the large storage reservoirs. So, in order to design a dam or plan any water resource project, we need to know that stream flow, right? Apart from that, we also the hydropower potential programming also being estimated with the help of the stream flow forecasting. And if we talk about in terms of the disasters, then flood is the major waterborne disaster which actually affects the life of humans as well as the infrastructures in recurring years. Like there are few states like Assam and the Bihar which normally deals with this particular disaster every year. So in order to how to reduce that disasters hazards, so for that we need to know this flood early warning systems, which solely depends on the flood forecasting, and the flood risk mitigation also can be done. Okay, so the stream flow forecasting is very much essential in order to deal with the flood, right? And this can be done in by modeling, obviously. And the models can be traditional models, which are basically the physical based or conceptual based model, such as SWAT, which is soil and water assessment tool, which is a very popular hydrological model. Apart from that, there are VIC, SPHY, Mike series of models, and HEC HMS. These are few of the very common or popular models which are physically as well as conceptually based, right? And the second category of the model comes as the artificial intelligence or the AI based data driven models, wherein we can have ANN models or the SBMs and so on, so many others. So, so we will be focusing on this artificial intelligence or the ANN particularly, right, in this talk. So you must be aware of that people get confused between the AIs or the machine learning ML or the ANN or the deep learning. So this particular slide I've taken from this HPE website. So they just try to clarify these terminology. If we talk about the artificial intelligence or AI, it is a bigger umbrella or a bigger picture, wherein any technique that enables machines to solve the task in a way like human do, that comes under the AI, or it you can say it's a very broad domain. And within that domain, one packet is there called the machine learning, which are nothing but the algorithms which actually allows computers to learn from the examples without training them exactly for that particular problem, right? And ANN, you can say the artificial neural networks, they can be a subset of the machine learning, wherein we try to simulate our brain, right? So, for example, in our brain, there are number of neurons which are internally connected. So we try to develop a model similar to our brain, right? And deep learning is a new concept which is growing up day by day, which is a subset of again of machine learning, which actually uses the deeper neural networks models, obviously, and they build on the based of the hierarchy of the data representation. So this is a very good slide. That's why I just try to put in here to make it understand what is the difference between these three, four terminologies. And if we talk about machine learning models, so there are many. For example, the MLP is the most commonly used neural network model, wherein we have multi-layer perceptron. Apart from is there the support vector machine (SVM) is there, the linear regression (LR) model, as well as the MLR model. The multiple linear regression models are also present there. But in this talk, we will be focusing on the ANN. So this is the introduction slide of the ANN. So ANN, actually the ANN models are inspired by the biological working of our brain. As I told you earlier, if you just see this figure, this is actually the representation of one neuron present in our mind. So these dendrites, which actually receive the signal from the other neurons, and these can be considered as a input in our ANN model, right? And this particular soma or the cell body, which contains the nucleus as well as, which actually this actually works as a processor of the model, wherein we apply some kind of functions. For example, we try to sum all the inputs, right? And we try to process the information received from the other neurons. There are few links which are connecting to the dendrites, to the cell body, and cell body to the axons. These links are nothing but the synaptic in the biological system, and in our ANN model, we call them as a link. And axons are nothing but these are the output which actually transmit the processed signal from one neuron to another neurons. So the concept of ANN is not new. It was started way back in 1957 with the single layer perceptron models. Then in 1960, the MLP or the multi-layer perceptron model come into existence. And 1974, the ANN with a back propagation algorithm has been evolved. Okay. The modeling goal is nothing but to simplify a model of our human brain and try to just mimic or try to copy that behavior and learning task in order to solve the given problem. So, overview will be given how we can use this AN in the steam flow. So, in order to better understand how the any machine learning model is different from the ANN, can be represented in this figure. If you see, suppose this is our machine. Okay, this is machine without the ANN, and we just try to train this machine with the help of picture of few dogs, right? So there are input pictures of dogs, four pictures. We try to train this machine, and then we give a random picture to the machine and ask where is the dog in the picture. So the machine may not be able to recognize this is the dog. Basically, this dog is different from the training picture of the dogs, right? But if the model is trained with the ANN, so what ANN do? ANN actually subdivide the main information into the small packets of the information. That means in terms of the various features. So the machine can be understood that yes, a dog must have a tail, it must have a nose, it must have a ear, 2 ears, and that is down. So variety of features the ANN model learns. And if you ask the ANN based machine model, where is the dog in the picture? Probably at certain probability, the machine can tell you, yes, this is resembling to a dog, right? So this is the difference between a model without ANN and the with ANN. So if we talk about the development of ANN model, so first we talk about the structure of the ANN. So if whatever kind of ANN model you are trying to develop, it must contain a few of these things. First would be the neurons. Obviously, neurons the backbone of the ANN models, which also called the nodes or the perceptrons, right? And there must be a input layer, there must be an output layer, obviously, and in between there may be one, two, or many hidden layers, and there must be a connection between the input layers to the coming hidden layers, and this must be assigned with some weights, right? These nodes are connected to each other, right? And the strength of their connection actually is defined by the weights, right? And we have to have a activation function in order to test that model whether our expected output is actually meeting to the observed values or not. And obviously, like any models, the ANN model also have some biases. Okay, and just to remember that all the different layers like input layer, output layer, and the hidden layer, they have three types of neurons within that. So they also call the input nodes, the hidden nodes, and the output nodes. So within each layer, whatever the neurons presents, they termed as a input nodes or the hidden nodes or the output nodes. So what is a neuron? What is the base formula of the ANN model? So the artificial neuron or a perceptron, which is the major part of the ANN model, right? And it actually simulates the behavior of the biological neurons. And what is it? So it is actually combining the inputs, comparing the input with the threshold estimated, and in order to try to get the final output of the model, right? And in any ANN model, simplest mathematical relationship, it can be represented with this linear term, wherein y is the output, x is the input. So it's a linear relationship. That's why y is equal to v plus weight into the input, where b is the bias, and it's a simple equation of the line. The second important term or component of the ANN model is the transfer function. So, in order to understand transfer function, we should understand that the neurons are connected one another, right, with the links, and that connection strength actually depends on their weights, right? And all the artificial neurons, they can be divided into two categories. First is they may be excitatory neurons or they may be inhibitory neurons. So what is the excitatory neurons? Actually, the strength or the firing rate of the neurons, if it is increasing with the number or the neurons, that is called the excitatory neurons, and as the and the vice versa, right? The stronger connection means the more excitations, and the weaker connections mean there is a more inhabitation. Okay, so in simple terms you can just understand that it is actually transferring your input information to the output for the next layer, or the transfer function can be represented as a mathematical relationship among the input neurons, right? So this will be clear in the coming slides. So transfer function is a basically mathematical transformation, right? And few of the common transfer functions which are used in the ANN models are, say, linear transfer function, wherein we can simple a linear relationship between the input and the output. The unit step transfer function, it is actually normally used in the output layer, wherein we just want to say whether the the output is okay with us or not. That means there will be only two probable decisions whether the output is okay or not. That means 0 or 1, right? And there may be some piecewise linear or threshold based transfer function wherein we have some threshold value whether the output is actually crossing that or not. And there are these three, the earlier three are for the linear systems, and there are a lot of non-linear systems are also available there. In order to model them, we need to apply this log symboloid function wherein the output actually ranges from 0 to 1. The transient sigmoid and as well as the radial base sigmoid. So all these are the mathematical functions which are required to transfer the appropriate information from the input layer to the output layer. And yes, importantly, there is one more term called the activation function. So there is a transfer function and activation function. People generally get confused what is the difference between these two. So the transfer function, as the name suggests, it used to transfer the transportation purpose from the input nodes to the output of the neurons, right? And the activation function, again, it is a transfer function only, but it is being used to check whether the output actually meets to the desired output or not. So that activation function actually applies on the very last or the output layer, whereas the transfer function, it is normally used between these hidden layers. Now we come to variety or the type of the ANN models. So there are basically two broad types of the ANN. First one is called the feed-forward networks, and obviously the feedback type of networks. So the feed-forward network is a non-recurrent type of network wherein the signal can travel only in the one direction or unidirectional. They can travel in only unidirection, right? So whatever the information, it is going from the input layer to the hidden layer and hidden layers to the output layer. Finally, we are getting the outputs from the inputs. So there is nothing like going back. Okay. And it is also important to just see that each processing elements make its computations, okay, based on the weights. So whatever the information is getting through the weights, it's coming over here, right? So whatever the output from this layer, it become input for the next layer, right? So this is an important, so that it is written as well as the new calculated value then becomes the new input value that feed to the next layer. So whatever the output from that one layer become the input for the next layer and so on. And this process actually continues till we reach to the final output product. Okay. And normally the feed forward networks are used for the data mining purposes, and they are both linear as well as non-linear. So this is the example of feedback type of network. So a feedback network, obviously the signal can travel in both the direction. For example, you can see in this figure as well as, so whatever the inputs we are feeding to the input layer, it is going into the hidden layer, finally reaching to the output layer. And if it is not meeting to the criteria, then again, we are taking the output of the output layer as well, input to the major input in the input layer as well. So there are all possibilities are there of the connection between the neurons. So this actually emerges as a complex networks, right? Since the loops are very much present. So this type of network is very much useful for programming or modeling the linear dynamic systems, right? Wherein the change is continuously occurring and the system is also modeling that changes. So this type of network are often used for associated memories as well as the optimization problem. Yeah, there is one more important term is called the back propagation. Normally, it's a feed forward type of network, right? See, the back propagation is a feed forward type of neural network, but it is different from the feedback type of network. How? Basically, in the back propagation, networks, it propagates the error in the backward direction. It propagates only error, right, in the backward direction in order to update the weights only. So the whatever the output layer, it is not coming into the main input layers. Only the weights which are assigned over here, that is getting updated with the back propagation process. There are few more types of ANN present, like MLP we have already touched upon. This is nothing but the multi-layer perceptron neural network model. It is the most commonly used type of feed-forward neural network, and normally it is being used in 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 collaboration with the, or in addition to this back propagation algorithm. Right? It is the most simplest one as well as. And based on the dependency, time dependency of the data sets, the all kind of neural network can be defined or divided into two categories: static and dynamic. Uh, in static neural networks, the input and the output vectors, they have some spatial patterns, but they are not temporally variable. Obviously, in the dynamic neural networks, the input and the output, they both they are they varies both in the space and the time, right? So the example of the DNN or the TDL or the RNN or the recurrent type of neural network. Recently, the statistical neural networks have been evolved extensively. Basically, they have extensive application in the non-linear modeling system, right? And the actual real life or real world problems are non-linear in nature. So that's why these networks are rigorously used in the field of say image classification or the simulation or time series predictions and so on. And most commonly used are the RBF, which is the radial based function networks, or the GRNN. So what exactly happened? The output of the hidden nodes, these are actually produced by the Euclidean distances, right? So in the RBF, we have the Euclidean distance between the input and the center of the bias function. So that's why it is called the radial basis function. So if you try to develop any ANN model, so these are few of the consideration you need to take, or you can say these are the design issues we have to always check on whenever we develop a ANN model. First one is the initial weights, which is very important. So obviously, initially we don't know any weight, so we assign some random values between -1 and 1, and then we try some function, then try to estimate some the our what is our observed or the actual output or the actual observed values, and we try to adjust the weight, and we also try to optimize our number of neurons. Then data representation has been done, and size of training set also, it's an important criteria or issues to handle. So let's take them one by one. So as I've already tell you, this transfer function is transferring the information, mathematical transformation of information from input layer to the outputs, right? So broadly, this can be classified into linear transfer function or non-linear transfer function, as well as some threshold based transfer function, right? So the error estimate or the model efficacy, obviously once we have some model output, so we need our model that what was the error in this model, or what was the model efficiency. So a variety of criteria are, for example, RS square is there, or the RMSE is there, or mean absolute percent, or some efficiency criteria like NSE is there, or KGE is there. So any criteria you can opt. Normally, people take one or two criteria in order to test their model's efficiency. Weight adjustment is very important, and it is actually done after each iteration, and it should be adjusted in order to minimize the error or in order to maximize the efficiency of the model. If we talk about the back propagation, which is nothing but an example of supervised learning, right? So wherein we have the error of the model, and then with the help of that error we try to adjust our weights, right? So how to adjust weight is given in this box. If you see, if n is our one neuron, right, and nw is the that neuron's input weight, and n out is the n's out, right? So what could be the next adjusted weight? It can be written as n adjusted weight is equal to n initial weight plus the delta NW, right? Delta NW is the increment which we are giving to the existing weight, right? And this delta NW can be defined, or it can be calculated from this formula, wherein we have the neurons output, right, and the error factor, neurons error factor, and this neurons error factor we can get from the neurons expected output minus the neurons actual output. So with the help of this formula, we can adjust the weight. Although if you are doing it by some say software or some programming, so manually you need not to do this. You need to define your ranges. Then all things will be done by the system itself. And obviously, this work can be done only for the last layer, as we have only the observed value in the output layer, right? Yeah, number of neuron is an important consideration in the models. See, if you take many on many number of neurons, obviously there will be high accuracy, but due to that number of neurons, the processing or the calculation of that modeling speed will be very slow down, right? As well as there will be a risk of overfitting. So what will happen if you give many neurons to the model instead of understanding the problem, the model will memorize the things. So this kind of developed model will not be useful for solving the new set of data. So it won't be a good idea to have many number of neurons. If you take very less number of neurons, then also it is not going to work for you. So it will be resulting in the low accuracy as well as inability to learn it out, right? So we need to go for some optimal number. Obviously, there is no certain technique in order to get the optimal number. We need to have some hit and try technique in order to get that. These are few learning processes our network can learn from: supervised learning, unsupervised learning. So supervised learning, as the name suggests, so we have a set of training samples as well as some uh, the observed value regarding that sample as well as, right. And in case of unsupervised learning, there is no desired output is required. That means we need not to have some observed value for training the model. Obviously, this is faster, uh, but the efficiencies or accuracies are less. And these unsupervised learnings are mainly useful for clustering problems or compression problems solving. This is a slide wherein you can find few software packages which are useful for ANN and other machine learning models, right? So these are few Python libraries which are freely available from these sources. You can use this. And normally people, this is most popular one, the Keras deep learning library, and it's have a really very recent functions as well as. There are few packages also available in the R language like neural net, ANN, RNN, and so on. Apart from that, few commercially available software like MATLAB and Minitab, they also have few packages of this ANN. And these are the most commonly used ANN models, which are popular in the research field nowadays. There are conventional AIs like MLP, extreme learning models, and some deep learning models like the convolution ANN, CNN, or the CNN with the long short-term memory network. And these are the recently evolved ensemble model, or the complex model, or you can say the hybrid model, the random forest decision tree, and so on. So again, we come to our main point, how we can apply this ANN modeling into stream flow forecasting, right? And I just try to present two case studies. One will be on the forecasting, stream forecasting, and second one on the soil moisture estimation. As I have told you, that stream flow is an important component of the water cycle, and I believe all of you must be aware of water cycle. So within the water cycle, you can see there are lot many processes are happening, which are non-linear in nature. So that is the primary requirement of ANN model. So it should be non-linear, right? And these are complex in nature. Apart from that, they are interlinked. That means there is a relationship, certain uh, relationship exists between the various components. So that also fulfill the criteria of the ANN model, that it is able to find the relationship between the different data sets or data classified, right? So this makes actually ANN models are very useful models in order to predict the stream flows. And stream flow forecasting can be a short-term forecasting. That means we are dealing with our forecasting are daily based forecasting, which are actually useful for the flood warning and flood mitigation system, as well as the daily operation of the reservoir or the dams. And there may be some long-term forecasting, which are actually used for planning purposes of maybe some water source planning, or maybe sediment transport and planning of hydropower and irrigation systems, and so on. And if you talk about the ANN model uses or application in stream flow, so these are few of the models which are popularly used by the researchers in this field, which are MLP or TDL, RNN, RBF, and so. So this particular slide is very important, and it actually describes the overall methodology, which includes the variety of different stages and the steps uh, for applying the ANN technique for the flood forecasting or the stream forecasting. So the very first is about the information or data analysis. Second one is about the model candidacy. Third one is about the model testing or validation. And finally, the selection of optimal model. In the very first stage, we just try to collect our appropriate data of the stream flow data series, as well as the input data series, which are actually affecting our stream flow, right? Then we try to just check our data quality check. So FOX is representing data consistency. It actually deals with the data consistency problems, selection of the input problems, right? So there may be n number of inputs available with us, but what are the appropriate input which are actually affecting the output? We need to sort out those inputs. So that means screening of the appropriate input that can be done with the maybe simplest form is the coefficient of correlation among the input and the input parameters and the output, appropriate output. Then we need to check on the challenges. That mean selection of neuron in the output layer, right? Selection of the neuron in the input layers, and we also need to try to establish the pair of the training sets, right? That mean what there may be possibility that there is a say set up 2-3 input parameter which is actually providing a very good result to the model. So that kind of exercise also we need to done over here, right? Then comes second step, that is about the selection of the model. Then in this case, we actually tackles what kind of the input and the output pairs we are providing to the model, so that the model can provide our give us a best results. Then we need to frame the learning and the training strategy, right? And once we have all this, then the model validation part or model testing part comes into the picture, wherein we actually evaluate the model uh, maybe graphically and statistically or both. And we also try to evaluate the model behavior. And once we are satisfied with the model, then we simply compare the observed and the or we optimize the model, right? And if we are not satisfied with this model, then we again go back and we just try to adjust our weights, or just try to readjust our input parameters. So now we come our first case. This is about the stream flow forecasting in springs, right? And the study area is located in the Uttarakhand itself. It is very near to the Tehri Reservoir, if you can appreciate over here, right? So the 5-year data has been used to train and test the model, and these are the three inputs we have used in this study. That is the precipitation, temperature, and the relative humidity. And that 5-year data period we have divided into two parts, that is training period and testing period. The first 4 year was the training period, and the remaining last, or 2003, we have tested the model, right? And in this study, we have used this back propagation in a neural model, artificial neural network model. It has been developed, and initially the model has been tested for the normalized system error, and we have tested each model for the 5000 iteration or the simulation, and our target output was the daily discharge. So what we have done, a network with a, we just take a random number, say 20 number of neurons, and we just try to you know take one or two hidden layers, then try to formulate a simple model, model number one, right? And wherein we have considered that this discharge or Q value is a function of precipitation only. So the model one you can see over here, Q at time t is a function of precipitation or rainfall at time t. So we simply take this model, and with the iteration 5000 iteration and initial weight, we just try to train that model, right? And we try to vary neurons from number 1 to 30. So 20 number of sub models for this one model has been run, and the ANN configuration will that we have tested using this model, right? Okay, in a single layer, and the network which is having the minimum layer. So within one model, now model number one, we got 20 sub models, and out of those 20, wherein we got the least error, that model is selected for this particular function. Okay, and then we try to incorporate another input, that that is that is model number two, wherein we consider that Qt is a function of the precipitation, the PT, and the PT minus 1. That means the rainfall on the same day and the rainfall on the previous day. So in that way, we have took now two inputs to the model number two, and so on. For example, in this way, we try to increase the number of input in the model. For example, in model number 7, if you can see, we consider that Qt is a function of the precipitation on the same day, precipitation on the previous day, temperature on the same day, and Qt, that is the discharge on the previous day. So likewise, we have taken variety of combination of the input parameters. Also very much required. With hit and trial, you can find out which is the most appropriate or optimal combination of the inputs, which is giving you the appropriate output. So in this study, we have considered these 7 models, right? So I believe, yeah. And with the results which have been tested against the normalized system error, we just try to identify which model is giving us the minimum error, right? So you can see in this table the model number 7, wherein we have 4 inputs. We have these 4 inputs: PT, PT minus 1, TT, and QT minus 1, right? And we got hidden layer, only one hidden layer, and number of node in the hidden layer were 8, and we got a node in the output layer, as we have only one targeted output Q, so it's 1 over here, right? And in other model also you can see the nodes here. In, for example, in model number 4, the 3 inputs were used, So model number 3, only 3 inputs. So see, 3 nodes are there and 4 hidden layers. Okay. So in this way, you can see once we have added the QT minus 1, the previous day discharge. So this particular model number 7, that is 4801 or 481, it is actually performing superior to the other models, right? And we also try to get a graphical efficiency of the model in terms of plotting the observed versus the simulated discharge. And you can see there is a close agreement has been achieved between the observed and the model simulated discharge. And model number 7 is found to be the best model. And it actually curtails the requirement of, and that also actually indicates that there is a previous day discharge. If you add the previous day discharge as an input to the model, it actually performs very much better. In this case also you can see this is the minimum error you can see in the model number 7. So this kind of model is very useful as steam flow measurement is a very Herculean task. It requires rigorous field work and it's very time consuming as well as energy consuming. And that we need to done at the final catchments or final scales. But there are few drawbacks of ANN in the steam flow as well as, so there is a slow learning rate, right? And it in between also it get trapped into the local minimas. Local minimas are the periods wherein we have very little flow in the stream, and if you have the rainfall, there is a sudden increase in the stream flows, right? The learning rate is a major issue in this ANN application in the stream flow. Apart from that, what could be our stopping criteria for the model? And overfitting is also a problem in stream flow. But apart from that, there are few advantages as well as. So it is highly reliable. The reliability of the model is very high, right? And actually, it actually simulates the non-linear functions very accurately. So that are the advantage with this. Now we come to the case 2, which is about predicting the subsoil surface moisture using the learning models or the AN models. So this is a study again we have done in a Himalayan catchment, right? Wherein we have taken only say 2 years data. The total observation was 658 numbers, wherein we have 525 for the training and 132 for the validation. So these were the 4 models we have used: the deep neural network, the SBM, MLP, and LR that has been used for this particular prediction. And our target output was the subsoil moisture. The soil moisture is a very tricky parameter to measure, right? And it varies a lot from place to place. So we were having this meteorological data with us, like rainfall, wind velocity, temperature, soil temperature, the top layer soil temperature, and the soil moisture. So we have taken this as an input and we just try to identify what are the input parameters which are highly correlated. So from the table you can see this the soil temperature at the top soil as well as the daily rainfall, these are highly correlated, and the soil moisture of the previous day, the T minus 1 day soil moisture is highly correlated with the output. So we have taken these inputs into our model and then try to get our results. So the results of the study can be seen here for training and testing part. You can see from the SBM, MLP, and LR, the DNN model actually performing very well among all these 4 models. So it is the deep neural network wherein we have multiple layers of the neurons in between, or the hidden layers were there, and we got really very good results. You can see graphically as well as during the training and the testing, the model actually achieves very close to the observed values or the actual values. So if we summarize the point that the ANN model, they can really can be considered as an information storage model. That means they actually memorize the past patterns and in order and then use that information in order to predict something. Application of ENN to stream flow requires a decision regarding four major aspects, but we have learned that selection of the variables which are actually best explaining to our output, that is discharge, designing the optimal uh, network architecture, selection of the best strategy to learn process, selection of the system that best represent the process, right? And the efficacy of any kind of ENN model for forecasting, it may be substantially improved using the multiple input parameters. So with a one input and multiple input, it can be enhanced, right? And those multiple inputs, we have to wisely choose or select from a sensitivity analysis as well as using that hybrid models, right? And DNN approach was most promising for modeling the subsurface soil moistures. And if we talk about the future research must include the application of the hybrid models such as CNN LSTM as well as the CNN RF or CNN, the rainforest, random forest, and so many others. And these can be work as a add uh, for the stream flow forecasting, waterside monitoring, as well as management uh, in the coming future. So that's all. Thank you very much. So in the last slide, if you can see, this is uh, a rectangular weir, compound rectangular weir, which is actually used for measuring the discharge or the stream flow in the field. And this particular weir we have constructed in the Himalayan catchment, what we have just presented over here. So you can just imagine the construction of the weir and then measuring. Yeah, thank you very much. If somebody having any query, then you're welcome.
Thank you, sir. I think we'll take up a short question and answer session. If anybody would like to address a question to sir, you can put it up in the chat box. We'll read it out for you. Okay, sir. I think questions. But if there are any questions and you would like to get in touch, you can take Dr. Neem's email ID and
Yeah, you can reach me at my email ID at any point
yes,
of time.
yes.
I'm
Thank you,
just
sir.
dropping it into the chat box as well as.
Yes.
Thank you very much.
Thank you, sir.
That's it.
Thank you, sir. Happy to have you here, sir. With this, we come to our second speaker of the day, Dr. Chetan Sharma, who will be speaking on disaster preparedness with future skills identified by NASSCOM. It gives me immense pleasure and honor to introduce Dr. Chetan Sharma. So, Dr. Chetan Sharma is a professor and head of Civil Engineering Department in the Jodhpur Institute of Engineering and Technology, Jodhpur, Rajasthan. He is having more than 9 years of teaching experience, industry, and research experience. Dr. Chetan completed his MTech and PhD at IIT Roorkee and undergraduate studies at MBM Engineering College, Jodhpur, Rajasthan. His research interests lie in the climate change impact assessment, urban heat island, machine learning models, and data mining, stochastic hydrology, changes in land use and land cover, and rainfall runoff modeling. He has published many research articles in reputed journals, books, and conferences. Renowned organizations like American Geophysical Union, United Nations Office of Outer Space, and DST awarded him the fellowship to present his research at international platforms. It is a great honor to have you here, sir. I would like to invite you to start your session.
Okay, so very thank you, Rakshit and Dr. Anupam Shukla, and I like to say my gratefulness to Mahe and NIDM officials to organize such webinar series. So, not taking too much time, I would like to start my presentation because it's already late by 15 minutes, I think, or 30 minutes. I'll just share my presentation. So I can just switch off my video if you don't
Yes, sir,
want me
sure.
to. Yeah, that will just be the problem. Okay. So is it visible, the presentation?
Yes, sir. Yes, sir.
Yes, sir. It's visible.
Yeah, okay. So thank you so much. Thank you all the participants to just be here and listen to things. So my title of this presentation is the disaster preparedness and with the future skills like NASCOM. I don't know how many of you have heard about the NASCOM, but this I will just give you a brief about this in my presentation. So this is the outline of my presentation. So I will just give you some brief about the disaster, its management cycle, and the role of IT in this, and about the early warning systems, and an example uh, where we can use the ITs and these things. And because of it is the soft skills, so we will talk about some data and the role of data analytics in this, and then the computational intelligence, then something about NASCOM, and ultimately I will just give you some briefing about the disaster reduction, readiness and response, and the use of application of soft skills in this. So ultimately, it is not a because this is just a short presentation, so I will not just be able to give a detailed example or a training on the exercises. So just it's a means descriptive type of presentation will be there. So if we look at the disaster, so disaster is not like a daily use things. We should be able to just um, will you just analyze what the disaster. So in the disaster, some things should be there. Number one is there should be a serious disruption of the activities of the humans or the population. There should be some serious disruption. Number two is it should occur for a relatively shorter time. Number three, it should have widespread loss and effects on society, industries, environment, anything. Then number four, it should exceed the ability to cope using its own resources. Like if the disaster happens, then anyone cannot just cope up with the things at its own. Like if there is some kind of short problem, like some mischief or theft is happened, it cannot be termed as disaster because it can be coped up. Fine, but the something which cannot be coped up on its own. So it is called the disaster. Then it is very difficult to predict the consequences of disaster, and the consequences are dependent on social infrastructure and natural environment. So disaster is not just a simple term to just say a definition. It it should consider all these points, and so it should call a disaster. And then coming to disaster management. So in the disaster management, the things are the to just be prepared about the disaster and be ready during a disaster, and after disaster what the things should be done, we should be knowing about these things, and the measures which is to be adopted to mitigate the uh, undesired consequences of the disaster. Fine. So this comes in the disaster management. Why I'm saying these things, because these are just a silly, means just very small definitions, and you must be knowing each and everything. But these things are related to the soft skills. So these things must be known to each and everyone. So this is the disaster management cycle. I know means a lot of you know about this, but just to give you a brief idea about this. So it is cycle. We cannot say where does it start, where does it end. So if I start with the preparedness. So in the preparedness, we should be prepared about the disaster. So there we should have some emergency response plans, and the proper training and exercises should be there, and the sirens, alarm system, early warning system should be there. So this comes the preparedness. So this applies for any kind of disaster, like if there is a fire accident is there, like a cyclone activity is there, flood is there, or avalanche is there, anything, earthquake can be there. So a lot of things are there. So we can just so there can be a lot of things can be there in this disaster preparedness. Fine. Then come the response. It is the thing when the disaster happens. So response means first our prime responsibility is for the life safety. It is the prime responsibility. So we should just look for the life safety. Then to stabilize the incident, whatever have happened, so that it should not escalate. Number three is the preservation of properties, like some damage have been happened, so immediately the stabilization should be there so that more damage cannot happen. Then evacuation of the survivors and then the sheltering of there and the caring of the mass, like the no disease should be spread and how the fooding, everything will be taken care. And after that, the third phase comes in the recovery. So recovery means now coping up, which I was saying in the disaster, like recovery of the economic management of debris so that the diseases and these things don't spread, housing of the survivors, health issues services, all these things are there. Then the mitigation. It is not after the disaster, but it should be before the disaster, like mitigation. So mitigation means how to mitigate the ill effect of disasters. Like it can be done by the public education, like in the earthquake, what should you do? In the case of avalanche, what should you do? So these are public education. Then assessment of hazard and vulnerability, like which areas are more vulnerable, what type of hazard can be there. So this assessment should be there in the mitigation, and the infrastructure should be improved so that there should be minimum loss or damage to the public health infrastructure, anything. So this is the disaster management cycle. So this was just a brief about this. A lot of things are there which can be covered in this. So now coming to directly to IT. IT, this is the information technology. So earlier in the year 2002 or 2003, 4, there was a lot of emphasis was given on the IT, information technology. It was a branch like BTech in IT and CS in this thing. Now the IT, the IT is just vanished. So, the IT, ultimately, everything is IT. The data which you are taking, the things you are doing, the soft skills you are doing, the analysis you are doing, the spatial data, everything is IT. So now what I think that is data science, machine learning, AI, these things, they are the just part of this IT. Ultimately, this is the information. So IT needs some data, and using the data by some softwares and these things, the data is analyzed and the situation is monitored, and on the basis of the data, proper decisions are made. So IT is having a very big impact and very big influence to monitor and manage the disasters. So ultimately, the IT is having all the big tasks in the management and mitigation of disaster preparedness and the pre-disaster activities like early warning systems. Okay, and the prediction of the occurrence of potential incidents, hazardous situations, vulnerable locations, and these things. During the disasters also, how the response should be there, where are the control points are there, where the damage is likely, where there is more damage is there. In the case of disasters, the IT is having a big role. And after the disaster happened, then response to the disaster. So each and every cycle of disaster, the IT is having a very big role, you can say. So this is the early warning system. It is also the part of this IT and these things, because early warning means there are three types of early warning system. Number one is alarm system. This is used when the disaster happens. Okay, so when just before the disaster happens, so that the alarms, proper alarms can be sound, so that the people can get evacuated or anything can be done. So the alarm system should be fully automated based on this IT technologies and IoTs. They should be able to detect the process in the real time. See what is happening, how is the severe things are there, and there should be automated that there should be some threshold that if the disaster severeness is becomes higher than that threshold, then it should be automatic. It should automatically sound. Okay, these things should be there. Then second thing, the warning system. This comes prior to the alarm system. That okay, the early warning systems are there. Like they should be partially automated. There is some data is collected from the environment and other things. It is before the disaster, and the decision is made by the threshold. Then ultimately by the machines, and the experts take the decision that okay, it should be termed as a disaster or not, and what kind of things can be done. Then number three, it is much earlier than the happening of the disaster. So that is the forecasting system. So the forecasting system. We have a lot of data in terms of satellite images, remote sensing data is there, and some historical data is there. A lot of data is there. So based on the data, using the machine learning techniques and the data science, we can just forecast see what is going to be there, what type of disaster can be there. So this is kind of preventive measures are there. Then like if I just want to go through the example of like in the case of flood, number one is we have to assess the risk. So first the risk knowledge. So in this, number one is a hazard. What type of hazard, flood hazard is there? In this we can assess that which kind of storm is there, the dimension, the area, the diameter of there, and how can we what can be the water levels can be there in that area, and the elements and the elements at the risk. So this is the elements which the industries or the humans or the societies, anything which can be at risk due to this hazard, and then the vulnerabilities, which areas can be more vulnerable. So this is the knowledge of the risk. Then at the time disaster or just before the disaster, this is the warning system, like how much rainfall is happening, what is the water level, and then on the basis of these parameters, the decision making. Okay, this should be termed a disaster or not, or what should be done for the evacuation we should go or not. So ultimately, then after during disaster, there should be the communication through the radio, TV, telephones, and everything. The warning should be there, and a lot of things are there, so it can be done. It can be done. A lot of things are there, and then the response capability. Then the disaster have happened, and we have a lot of data about how the disaster has been happened. What are the damages of the property? These things are there. So analyzing the data, we can just focus on the evacuation center, and we can search for the survivors and the rescue, and we can arrange the relief goods. Right. So ultimately, these four things are there, but as you can see, there is one thing which just associate these all parameters, like that is the data. Everything you can see, data is there. Hazard, you have the data like satellite data, imageries, the wind velocities, the sea level pressures, the sea level temperature, everything is there. Elements of risk need the GIS data. Vulnerabilities also need the GIS data. Rainfall means you need the weather data. The rainfall level needs weather data. And decision making also needs a threshold, which also comes from the data. Radio, TV, signal, radio, TV, telephones. This is also data that which area should be message that there can be something disaster is happening or whatever things are there. These are the telephone numbers where you can contact, and the evacuation center also, that where should be the more emphasis should be given in which site. So all of things you can see this in this example of flood. Each and everything is there is depending on the data. So when there is a data, there is a data science or some soft skills are there. So ultimately, which kind of data we are talking about in the disaster? So it is number one is the unstructured data. So the unstructured means that cannot be quantified properly. So like some news articles are there, uh, some activity reports are there. So there is some hashtag are the hashtag Katrina flood was, Katrina storm was there, hashtag this was there. So based on these hashtags, there is some soft skills are there. They search for these kind of hashtags, and they search that which kind, in which area, which location hashtags are more. So by that they can just collect the unstructured data. Then comes the structured data. That is the like previous report, the damage is there, and some earthquake was there. So what kind of earthquake was that, and everything was there like previous in the base of proper quantified data. Number three is the remote sensing data, which can be just get from the mobile images, which the people just show, record, and just post on the Twitter or on the YouTube or the video devices or something like that. Then we have the spatial data, which is in the form of satellite imagery, and then audio video communication, like whenever the some people just dial number 100 or 101 and just 103, and just they just say that okay, there is some disaster is happening, fire is there, earthquake was there, oh, a lot of things are there. So this is data is this type of data tells us that which data is really the point of interest, or which data is really not useful for us. So this is a hell lot of data. So for a person to just identify, read, and analyze this data, it is really not possible. So we need the machines to learn, analyze the data, and we need some decision, some threshold. Okay, this data should be considered a disaster. This should be not considered disaster. And disasters are very quick. So quick decision should be there. So by analyzing this much of data and to be very quick on the decisions, we need the machines, computers, soft skills, technologies. Okay, so these things are there. So to apply the analytical techniques, we need some machines. So the data can be, because data is very, very heterogeneous. So data can be just static or dynamic. Static means the data which is just priorly known to us, and we have done some simulations, and we can just analyze, okay, if this thing happens, then this can be the uh, quantum of disaster. These things are there. Then the dynamic data. Dynamic data is the data which is in the at the time of disaster, which is happening in the real time at the event. So at that time, the weather parameters, states of river, and the units where the response units are there, how the resources should be distributed. So that's the dynamic data. So all this data is to be analyzed properly using the machines. Now, ultimately, the challenges which we face in the availability data. The data is very important in the data science and soft skills, and the availability of good quality data is really very, very important and really very challenging because it is not really that much easily available. Fine. So in the general state, when there is no disaster, so you have a lot of sensors are there, satellites are there, you have remote sensing, data, platforms are there, okay, cameras are there. So in the normal case, you can just get the data. But when the disaster happens, all your data collection devices and everything can be damaged due to disaster. So at the time of disaster, it is very difficult to just analyze the dynamic data. So this is the real challenge. So and the most important phase of any disaster is at the time of disaster because you have very less time to save the lives. Okay, so this is the challenges with the data analysis in the disaster management. So the aim of this is to just quantify the data and just extract the data which is really, really important. So this is important, relevant. So for this we need the data science, the machine learning, and the soft skills. You just collect the relevant data and discard the irrelevant data and just get the information as quickly as possible. So in this analytics, in the disaster management, it can be divided into these five things. So analytics can be descriptive, like you have the data, you will review, examine, and you will understand. That's descriptive. Then diagnostic, that we have the data, analyzed, then we will see that what have happened, how much the damage, and why these things were happened. So these the data should be needed. Then predictive, like the forecasting, like okay, this is the current situation, history says this. Then on the basis of this, we can decide that okay, this can be happen. Then a prescriptive. This is real time on the basis of dynamics. Like this is the history. Now currently these things are happening. So in the future or in the 1 hour or 2 hours, the things can be worsened like this. So this is a prescriptive uh, analytics. Then decisive. So based on these parameters, the decision should be made. Okay, this is the quantum disaster. The decisions to manage the disaster should be taken like this. So these are some alternatives are there. So this is a part of all data analytics. Now coming to this computational intelligence or soft computing. So I was just totally talking about the data and data and data because ultimately the data says everything and a lot of things, and sometimes it can be relevant and unrelevant. So using the soft computing, we can just have IoT and this AI and machine learning, a lot of things can be there. So we should know that this data is relevant, this data is relevant, and based on this, we can extract the information. Fine. And in the soft computing, lot of the parameters, lot of the models are black box models. So because to model each and everything using the mathematical tools, it is not really possible or not feasible because they are very, very complex. And it have a lot of dimensions in it. So to understand the parameter which is depending on multiple dimensions. we need the soft computing. So I will just go in detail in the next slide. So the NASCOM. The NASCOM is the National Association of Software and Service Companies. It is a non-governmental, non-profit organization, and that is really a very big organization that looks after the training of the companies. A lot of things are there. Even our Prime Minister have praised the efforts made by NASCOM to just train and aware the faculties, students, and others. So, the Secretary project was there in the of the MHRD. They have collaborated with the NASCOM to train the students and the faculties and institutions to in the future skills. So, as per the NASCOM, they trained the faculties in 7 future skills. First was the AI, artificial intelligence. Second, the blockchain. The blockchain is there, the cryptocurrency and these things. They are using blockchain, but blockchain is having a lot more applications in this disaster management. Then cybersecurity, data science, Internet of Things, IoT, robotics, virtual reality, 3D printing. So these all many other future skills are also there. But these 7 are really very big in the terms of disaster management. And this MHRD have identified these skills, and they are associated with the NASCOM to train the institutions, faculties, and the students. So till now, I think more than 1,600 faculties have been trained with these future skills, and each of them have trained at least 60 students in at their institution. So you know how much they have been succeeding to disseminate the knowledge of these things, future skills. So in the disaster reduction, what we call reduction is just reduce the risk of occurrence of disaster and possible consequences. So for the reduction of disaster, what we need the proper data. This was the case of historical data we are having, and we have the weather informations are there, or fire conditions or temperature data we are having with us, and based on this data we analyze that okay, in the history these were the conditions which triggered that kind of disaster. Okay, so based on if these similar things are happening in the current scenario or they will happen in the future, so on the basis of that scenarios we can just say okay, this kind of disaster can happen in that area. Okay, so if we know that at that time this kind of disaster can happen, we can easily reduce the ill effect of it. Fine. So soft skill is having a very big role to just reduce these uh, disasters, like to assess the likelihood of incidents and incidents. A lot of incidents are there, like it can help to prevent the fire because the temperature is there, and wind velocity is like this. In the case of forest fires, it can be done, and like if you can, it can see like in the case of terrorist attacks by just analyzing the social networks and the sensors and the CCTV footage and these things and face recognition. We can do a lot of things. So soft skills is having a lot of application in the direction of disasters. Number 2 is the readiness. So how much we are ready to face the disasters. So in the readiness that comes when the disaster happens. So it can be the evacuation planning. So soft skill having a very big role in the planning of evacuation, which areas can be suitable to just hold the survivors, or which area can be safe for the survivors, and a lot of things are there. So you can just these things, that shelters in the case of flood, in the case of earthquake. There was the earthquake in the Bhuj. Okay, so a lot of issues were there. A lot of peoples were displaced. Survivors were there. A lot of camping and these things were there. There were the problem with the food and these things. Problem of medicines were there. So resource allocation and these things and the management of resources, everything should be done with using the soft skills, because that can be very easy. Then comes the response. So response means how we are responding to the disaster. So we have the real-time satellite images are there, like that this much damage has been happened. We have the CCTV images are there. We have the data of the crowd, the population which is being affected. We can simply want the police and the NDMA persons to just go there and just do the things. And in the COVID conditions also, it was like a disaster for a lot of us. So the robots can also be used to just go the places and search for the rescues where the humans cannot go, and to just contain the contagious diseases. The robots can be used. So here the robotics can be used from the soft skills. So you can know that a lot of examples are there which use the soft skill, the advanced technologies, the future skills to mitigate and analyze the disasters. Fine. So in the summary, you know that the lot soft skill like data science, AI, and machine learning, IoT, robotics, cloud computing. A lot of things are there, so we can use these things to just assess and analyze the data, assess and analyze the disasters, and we can make the precautionary measures to just mitigate the things. And for the training of peoples also, it can be used. And for the quick decision making, we can also use the soft skills. So it is having a very wide range of applications in the disaster management, the preparedness. So that's all from my side. If you have any question, then please you can ask. So I know that was very quick and that was very theoretical, but this time I was not really having that much time to just go with the experiments and the practicals.
Okay, sir. Next time, I think we'll try to give you more time. So much more
Yeah,
into.
yeah, thank
Thank
you.
you, sir. This we come to our third speaker of the day, that's Dr. Childas, who will be speaking on applications of soft computing techniques in water resource management. So it is an honor to introduce Dr. Childas. He's working as a research associate in the Department of Civil Engineering at the National Institute of Technology, Warangal. He has completed his BTech in agriculture from College of Agricultural Engineering and Technology in the year 2000. Master's and PhD in Water Resources Engineering from NIT Warangal itself in the year 2013 and 18 respectively. During 2018 to 19, joined as Research Associate, Discipline of Civil Engineering at IIT Indore. His research interests and activities are climate change impact assessment, extreme value analysis, non-stationary analysis, hydrological analysis and modeling, crop modeling, analysis of compound extremes, and ensemble forecasting of hydrological extremes. It's an immense pleasure to have you here, sir. I would like to invite you to start the session.
Yeah, thank you, Rakshit. And so, shall I share my slide?
Yes, sir. Sure. So you can even turn off your video, sir, because of some bandwidth issues. Yes, sir.
Yeah. Is it visible?
Yes, sir. Visible, sir.
Okay. So, thank you once again, NIDM and Manipal Academy of Higher Education for conducting these 3 days workshop. So today I'm going to show one application on soft computing techniques, which was used in future projection of stream flow over a Indian river basin. So this work I have taken from my earlier published paper, that is in Hydrological Sciences Journal. The title was Assessment and Evaluation of Potential Climate Change Impact on Monsoon Flow Using Machine Learning Technique over Venganga River Basin. So Venganga River Basin is the largest sub-basin of Godavari River. So this is the study area, and these points are the NCP grid points. So I will talk about these NCP grid points when I show my flow chart. So this is the dam of the Venganga River Basin. So this is the complete methodology. So this is the flow chart. So here I have used NCP as a reanalysis, the NCP as a observed data, which is a reanalysis data. And for future projection, I have used this GCM output. And here I have taken 40 GCMs for the projection of stream flow in future. Then next step, what we did is we standardized the NCP data as well as GCM data in order to minimize the variation in the range of different variables. Then we perform the principal component analysis to find out the different principal components. We use principal component in order to reduce the dimensionality and correlation among the predictors. And as you know that NCP grid points and GCM grid points have different resolution. So in order to bring them a common resolution, we have performed interpolation. So GCM predictors, that means GCM data are collected over the NCP grid points through interpolation. Then we perform this principal component analysis in order to reduce the dimensionality. So the maximum number of principal components we have taken, which is like combined percentage of variance is more than 90%. So here you can see here we found 4 principal component who combinedly showing more than 95% of the total variance of the total data sets. So here we are projecting stream flow. So that's why the stream flow is the Y. So X are that is also known as the predictant. So in order to project the stream flow, we have to take the predictors. That means the atmospheric variable which are affecting the stream flow. So here we have taken the different predictors. Those are mean sea level pressure, specific humidity, 500 HPA, geopotential height, as well as surface temperature. So it should be mentioned that precipitation can be important predictors for stream flow. But however, in an earlier study, we found that in order to forecast the precipitation, mean sea level pressure, specific humidity and 500 HPA geopotential has been considered. So here, instead of precipitation, we have considered these 3 predictors along with the surface temperature. Just a minute. Yeah. So then what we did is we, after finding out the principal components, then we clustered those principal components using fuzzy clustering. And here we used FPI for fuzzy performance index using this NCE. So NCE estimate the degree of disorganization created by a specific number of classes. So the base of the selection of the number of clusters based on the NC value, when NC value approaches nearly equal to 0.25. So here we have tried different different cluster numbers that varies from 2 to 10 and FPI NCA values. So M is a parameter here, but here you can see that the FPI value is nearly equal to 0.5. So we have taken the cluster here in case of 3. So cluster number 3 and NC value is 0.5 and membership function is equal to 1.4. Just a minute. Okay, so these are the different climate models. I've used 40 different climate models under RCP 2.6, RCP 4.5, RCP 6.2, and RCP 8.5 scenarios. So all the climate models doesn't have all the scenarios. So where there are the model where there the simulation for different scenarios are there, we have taken them. For example, XS 1.0, it doesn't have RCP 4.2.6 and 6.0. So we have taken consider 4.5 and 8.5. So like this, for different climate change scenarios, we have taken different climate models. So in order to project the future stream flow, and one more important thing I need to explain here. So future stream flow can be modeled through a meteorological variable force through a hydrological modeling, or we can use a black box model like machine learning technique in order to model the past stream flow and then project into the future. And it should be noted that when we use the physical-based model, that is hydrological modeling, we need a lot of data sets and metallurgical data as well as morphological data as well as physiological, all those data sets we require. So, but in case of machine learning, the advantage is we need a minimum data and that understands the link between the output and input. Then accordingly, it model the predictant. So here we have used support vector machine and labor vector machine, relevance vector machine. So in case of support vector machines, so inputs are mapped into nonlinear mapping. So actually what it does is first it put into the input data into high dimensional feature space. Then a linear model is constructed in the feature space using this equation. So k, xi, x and wi are the kernel function, and different types of kernel function are there. For example, radial based kernel function is there, Gaussian kernel function is there, and here B is the bias. So every time the model go through the input data and output data, accordingly it adjusts its bias, and the quality of estimation is measured through this loss function. So you can note that for most of the hydrological analysis, linear regression we can do. These are the non-linear type regression, but some cases people also use linear regression, which is not that much appropriate in case of hydrological analysis. Thus, non-linear mapping using a kernel K is used to map the data into higher dimensional space feature, where this kernel and linear is performed. So there is a difference between support vector machine and relevance vector machine. The main difference is the number of parameter. So the number of parameter is less in case of relevance vector machine, where the number of parameters is more. So these are the disadvantage of other machine learning technique. So these are not like other machine learning techniques, more parameter, and predictions are not probabilistic, and the parameters of other machine learning techniques are not straightforward to evaluate. So, but all these things are not there in 11 vector machine, which is quite easy to perform. So we have considered these two different machine learning techniques. So how we do the model evaluation? So this is a metrics performance rating matrix provided by Moriasis in 2007. It has given RS, R and NSC and P bias value and their range with their different performance rating. So these are different equations for those performance rating. So NSC, P bias and RSR. And here we have taken Gaussian kernel function for SVM and Gaussian and Laplacian kernel function for RVM, and we have trained the historical data that is from 1970 to 2000 and divided into 70-30%. That is 70% training, 30% in testing. So we've computed the R, P bias, RSR, NSC, and this is the overall NSC. So based on this, you can see that the RVM with Laplacian kernel function is showing a better training and testing function with P bias under category of very good, RSR under category of very good in training, and satisfactory in testing. So overall NSC is very good in case of RVM with Laplacian kernel function. So we have taken this machine learning, this kernel function with RVM in order to project the future stream flow. So this you can see, this is the Taylor diagram where you can see this RVM with Laplacian kernel function is nearly close to the observation, whereas others are quite away from the observed data sets. So we have used here. So this is the modeled observed data, and these are the model data using the NCP predictors. So you can see that in case of RVM Laplacian, is quite like a good agreement between the observed and model data. So using that model data model, so we have projected for the future. This is the projection for RCP 2.6, and we have divided the future period into three different parts. One is 2011 to 40, 41 to 70, and 71 to 2100. So here first one is the observed, and these are the different models. So the B1, B2, based on the initial of the climate models. So you can see that there are no significant change in case of observed data, and though there is significant variability with respect to different GCMs, but there is overall there is not significant change with respect to observed data under RCP 2.6 scenario. But similarly, in case of RCP 4.5, we found that there is a quite variability among the GCMs while projecting for the monsoon stream flow over Venganga River Basin. Similarly, we have done for this RCP 6.0 and RCP 8.5. So then we established a relationship between the stream flow and temperature. And here we have taken the ensemble, the total, we have plotted all the data in form of box plot. Here you can see in RCP 2.6, RCP 4.5, 6.0, and 4.8, with increasing radioactive forcing the stream flow. Here you can see there is, though there is decrease in high flows, but there is a increase in mean flows. You can see in case of RCP 2.6, and similarly slight increase in mean flow in RCP 4.5. And with respect to RCP 6, in case of RCP 6.1 and 8.5, you can see slightly decreasing during 2070 to 2100, and the reason can be attributed to the increasing temperature. And this relationship also was found by Suimal Ghosh and Mujumdar when they performed this analysis over a different river basin in India. And then we plotted the flow duration curve under different scenarios. Here you can see this blue color. You can see this is the observed flow duration curve, and these are three different future projected flow duration curve. You can see the high flows are decreasing, and however the dependable flow over 0.5 probability is increasing in case of 2.6, and similarly in case of 4.5 and 6.0 and 8.5. But however, the high flows are decreasing significantly. And here we found the uncertainty associated with the future flows under different scenarios. You can see that in case of high flows, the uncertainty range in flow division curve is less as compared to the low flows. So here also we establish a relation, means here we, okay, here we found the change point analysis. Actually, when the flow is changing over the river basin, in case of here we use Bayesian analysis to find out the change point. Why we use Bayesian analysis? Because there is a probability of a change at any year. So we used to calculate the probability of change at each year. Then where the probability is high, then we call that year as a change point year. So here in case of observe the mean annual monsoon flows changed during 93 and 94 based on the posterior density. However, in case of RCP 2.6, 4.5, RCP 6.0, and 8.5, we observe that for RCP 2.6, the change flow, the change point is observed during 2070, whereas in case of RCP 4.5, 6.2, and 8.5, it is observed around 2055, in between 2055 and 2060. So here the conclusion is like the change point in case of higher emission scenarios, the change point will happen much earlier than the low emission scenarios. So usually, so this is a work we carried out over this Venganga River Basin during my PhD time. So that's all. The basic conclusion of this study was the low flows are going to increase, but the high flows are going to decrease. And there is a significant relationship between the temperature and stream flow. With increasing temperature, the stream flows are decreasing. And this machine learning technique, where we found the RVM is outperformed the SVM, and this machine learning technique can be used to project any other hydrometeorological variables. But nowadays, due to increase in this computational facility practice, we can use the improved version of this machine learning technique, and people are using like deep learning technique, for example, short long-term memory. Such kind of application can be performed in WaterUses in order to develop a sustainable management plan and reduce the disaster, reduce the risk. So that's all from my side. Thank you.
Thank you, sir. Thank you for presentations. Let's take a question for or you can feel free. Or you can feel free to contact sir through his email ID.
Yeah, sure. Yeah.
Thank you. They're not. Thank you for your presentation. So,
Thank you.
okay. With this, we come to our fourth speaker of the day, that is Dr. Shweta Vaidyadas, who will be speaking on geospatial applications in oceanic disaster management. Special reference to oceanic earthquake or tsunami, oil spill, and algal. It is an honor for me to introduce Dr. Shweta Vaidyadas. She has done her PhD in oceanography from National Institute of Oceanography. She has worked on the paleoclimate and monsoon shift from last glacial maximum to Holocene. Later, she was working on glaciology in Jawaharlal Nehru University and Ministry of Earth Sciences. She also taught disaster management at Jamia Millia Islamia and currently is working in National Institute of Disaster Management as a research associate, climate adaptive planning for resilience and sustainable development in multi-hazard environment, shortly named as CAPRES. She is also a consultant in ECDRM division of NIDM. It's an honor to have you here. I'd like to extend a warm welcome.
Thank you so much, Rakshit. And I will start my slides without wasting much time, since I think we are crossing our time, right? Is my
Yes, ma'am.
screen
Please go.
visible?
Yes.
Yes, ma'am.
Right. And is it moving?
Yes.
Perfect.
Yes.
Okay. So today we will look into three scenarios of oceans where we are facing severe disasters, and also we are using soft computing, or I will say the big data, and also the satellite imagery for understanding the problem, and also for understanding the the variety of problem, and also to identify the causes and the severity of the problem, and that will ultimately help us to bring out the solution for this. So let me start with tsunami. So you all must be remembering that on December 26, 2004, there was a severe tsunami incident at local time of in the midnight 12:58. A magnitude of 9 earthquake hit the Sumatra Andaman Island. So this earthquake actually caused a secondary hazard, that is tsunami. So we have to understand that this earthquake was generated under the water, ocean water, and I will come to the details of how this had happened. And here, let me tell you that this is one classic example of cascading disaster. So what is a cascading disaster? Normally, whenever there is a disaster, so the primary disaster is something else, and that gives rise to other disasters as well. So let's take the example of this. So the primary thing, what happened is a earthquake. So, but ultimately the earthquake is not the thing which created problem for human being, because the earthquake happened below the seawater, but that earthquake gave rise to too much of movement of water, and that created the problem to people. So ultimately the secondary hazard that gave rise to the problem, and then that water came in, that created flood situation, that killed so many people. That is another problem. So this is how you can see that so many things happen together. So that is what is known as the cascading disaster. So this also happens, suppose whenever there is an earthquake in hilly regions or mountainous regions, that also gives rise to other disasters. Like the first thing will happen is landslide, then also some mud flow or debris flow can happen, and then that will kill so many people, that will create problems to the local people. So these are the cascading disasters. Now let me come back to the tsunami event. So this huge tsunami actually killed lakhs of people were missing, and then millions of people were homeless. So let us understand that how exactly it took place. So before going to that, let me tell you that that tsunami which happened on 26 December in 2004 is not the only tsunami. Before that also we have faced many other tsunamis. So in this table you can see that other tsunamis were also there, but you must see that the other tsunamis were there, but the magnitude of the earthquake was the maximum for the tsunami. So this is why this tsunami was so dangerous and so deadliest for the humankind. So now let us understand the process that actually gives rise to this oceanic earthquakes, or how exactly things happen. So for that we need to understand the plate tectonics. So what is a plate tectonics? So wherever we are staying, or how do I say it, the entire surface of the earth are divided into few plates. So these plates are lying, or I will say floating on a liquid, semi-liquid layer that is known as the asthenosphere. So this orange color layer, and above that this entire lithosphere is a combination of few plates. So those could be oceanic plates, those could be continental plates. Now what happens is also the plates can be a mixture of both oceanic and continental space. So what happens is this asthenosphere, due to enormous pressure and heat, this becomes semi-liquid, and these plates are moving on this asthenosphere. So while moving, what is happening? Sometimes these plates are coming together, sometimes these plates are going apart from each other, and sometimes they are just moving parallel to each other. So there are different names for this kind of plates. Let me come to the next slide. So when two plates are coming close to each other, that is known as the convergent plate boundaries. So here all the black lines are the convergent plate boundaries. When two plates are going apart from each other, that is known as the divergent plate boundaries. So all these red lines are the divergent plate boundaries. And there are transform plate boundaries, this pink color thing. So transform means they are moving in parallel to one another, they are not harming each other. Now what exactly happens in these three types of plate boundaries? So if we consider the convergent plate boundaries, that is the black color plate, these black lines, these convergent plate boundaries, wherever it is there, what is happening? Whichever is the heavier plate, the heavier plate is going below the lighter plate. So what is happening is lots of lava will come up at that place, because the plate which is going below that ultimately will be melted and lava will come up. So that lava will create sea mounts or volcanic eruptions. Sea mounts are generated through these volcanic eruptions. And what is happening is, because the head which is going below the lower or the lighter plate, that actually melts, and that creates the lava and that comes up. Now, what is happening in the divergent plate boundary? That is this red color plate boundaries. Here, two plates are going apart from each other, and that is why there, new sea floor is creating. So that is why whenever there is a divergent plate boundary, we are actually gaining landmass. And where there is a transform plate boundary, there, some kind of fault lines are created. So this is how three types of plate boundaries are there throughout the globe. Okay, so now we have to understand that here you see the heavier plate is going below the lighter plate. So here lot of volcanic activity or eruption is going on. So now this is the thing which happens when tsunami is there. So what happens is, in that convergent plate boundaries, there, since the lot of landmass, they are going below, and suddenly too much of pressure is released, that itself creates an earthquake, and that earthquake shakes that entire place, and that helps in a vertical movement of a huge amount of water. Because here you can see that amount that is going below, that itself creates that earthquake, which forces the nearby water to fill that gap, and that is why it creates tsunami. Because when a huge vertical movement of water is there, that comes to that not only comes to the coast, even if it is far away from the coast, it travels that entire distance, at it ultimately lands up on the coast, and that creates the tsunami. So normally tsunamis are seen whenever there is a convergent plate boundary. Okay. So normally we can see in a Pacific, Atlantic, and in Indian Ocean, in Mediterranean Sea, and in these are the places where we can see the tsunamis. And as I mentioned, that these long distance travel by tsunamis, these are known as the tele tsunamis, and it is not very normal that it travels up to 1,000 kilometers, and that entire vertical water mass that is moving for 1,000 kilometers. So you can understand how much mm, the magnitude of the I will say the movement will be when that is hitting the coast. So that is how it is very dangerous for all the places where it is hitting. So we have to see that we have had many deadliest tsunamis, like in China Sea, in Indian Ocean, in Japan Sea, and in northern Chile. So over the last 1200 years, more than 70 tsunamis had taken place, and lakhs of lives have been taken by this kind of tsunamis. So now let us look into what exactly happened. During the December 26th. So you can see that in December 26th, actually many things happened together, and that is why the tsunami was so deadliest. So let us look into those. What are the things those happened? So first of all, the earthquake itself was of very high magnitude. It was 9. So we can't even imagine if 9 magnitude of earthquake, if it takes place, so how terrible that will be, if even if it is on the land. Because normally we see, even if 6 or 7 earthquake is there, that itself is too big. And if some 8 magnitude of earthquake is there, then almost everything will come on ground, all the buildings, everything. So therefore 9 is too much, whether it is in water or whether it is on land. But what happens is, first thing is, the high magnitude earthquake took place. You can see in the left hand side picture, that epicenter, earthquake epicenter is given here. So second, what happened? So it was a convergent plate boundary, and third, it occurred off the coast in the deeper water. So what is happening is, when it is in the deeper water, then the depth of the water is more. That means if it is closer to the coast, then there is no much water that can come to the coast. But if it is going deeper, then too much of water can come to the coast. Okay, because it is of higher depth. And then third thing is the focus of the earthquake was shallow focus. So we all know if it is shallow focus earthquake, it is always more dangerous. So the focus was shallow within 70 kilometers. And then the rupture that happened, that means the I would like to show you here actually that how sorry, it is not going up. Yeah, so see here, this black color line you can see where Indo-Australian plate is written. This is the place where this is a convergent plate boundary. You remember I mentioned that black color is the convergent plate boundary. So if this is a convergent plate boundary, and here itself that earthquake happened, because I told you if it is a convergent plate boundary, there is a more chance that tsunami will happen. So this is the place here, you can see a very closer picture. So here that earthquake took place, and what happened is the amount of rupture that took place due to the heavier plate or the Indian plate that was going below the Burma plate. So there that rupture was really very big, and it was almost 1200 kilometers. And this rupture released a stress, and that developed too much of pressure on the water, which ultimately went up to the coast. So now you can see that all the places where here everything has been marked with the use of GIS, and here they have marked the relief activity map. So basically what they have done, wherever relief was given for Indian Ocean earthquake or tsunami disasters, those places have been marked with using the GIS map. Here the Tsunami Intensity Map has been prepared for Indian Ocean and surrounding areas. So all these round shaped things are the intensity map. So you can see here the intensity was 5 for Indonesia. So this is for the year 1883. So they have actually marked these areas from the years 416 to 2004. That means the latest tsunami. So you can imagine that data itself is really interesting, because they have taken data from 216. So the older data is also there. So that is how these are the interesting thing. And here along with the plate boundaries, so see here they have mentioned, I already mentioned you that this is the convergent plate boundary, this red color line here, and here is the place where the tsunami was originated. So they have marked the entire place, the epicenter and the plate boundaries. So now let us come to the algal blooms. So algal bloom is a very, I will say, interesting thing, and also very difficult thing for the productivity of any of the water. So normally what happens is the water gets instigated by pollution or changing temperature, and what is happening during the algal bloom is the entire water. I will explain the reason, but let us understand first that due to some reason, the nutrient content of that water is suddenly increased. Okay. So this is known as the eutrophication, because whenever there is a sudden increase in the nutrient content, what will happen? Lots of chlorophyll will be generated. That means lots of phytoplanktons will be generated. So when lots of phytoplankton is generated in any of the water, if it is very sudden, then what happens is that itself creates the scarcity of oxygen content in that water. So if scarcity is generated in that water, then whatever aquatic life is living there, they will be dead. So this condition, this less water, less oxygen condition is known as the eutrophication, too much chlorophyll. So what happens is, in some of the water, suddenly, so I will tell you, say if a place is very close to the coast, then during the monsoon, much nutrient flow is there in the water. So I am telling you about the coastal areas where some river is flowing and going and meeting the ocean, because that river is taking lots and lots of nutrients from land and that they are disposing into the ocean water. Now what is happening is, you can imagine, even if it is a rainy season, then also due to the sheet flow, or whenever it is heavy rainfall is there, so that sheet flow also is taking lots of nutrients from the land and that they are depositing into the ocean. So there is a possibility that during the monsoon season, normally this is in this type of overwhelming growth of phytoplanktons are increasing, and that is known, and that situation is known as eutrophication. Now we have to understand, if we are going into the middle of the ocean, there this eutrophication is not seen. There what we see is oligotrophic condition. What is oligotrophic condition? So whenever you are going to a deeper ocean, there the nutrient content is very less, because this nutrient is basically coming from where? From land. So whatever nutrient pool is there, that will remain very close to the coastal areas. So that hardly goes to the mid ocean or away from the coast. So therefore in these areas, the nutrient content is very less, because nothing is reaching there, or very less amount of nutrient is reaching there. So what is the source of nutrient there? Basically the decomposition of the aquatic life after their death. From there only the nutrients are reaching there. Now you will be very surprised to know that in Arabian Sea, before that I will tell you that wherever nutrients are high, the productivity is more, because whether it is fish or any other aquatic life, they also need something to eat. Okay, so they are not getting any nutrients, so chlorophyll is not increasing. That is why the fish who are secondary feeder, eating the phytoplanktons, they will not be able to live. So that is why most of the productivity is um, uh, restricted to the coastal areas. Now what is happening is, the Arabian Sea has a beautiful thing that is happening here. So in Arabian Sea, I will say millions and millions trucks of dust is coming from Arabian deserts. So what they are doing is, this millions and million trucks of sand and very fine soil that is being deposited into Arabian Sea. Therefore in the Arabian Sea, even if you are going in the mid ocean, that is there also nutrient availability is too high. Now how this sand or soil fine soils are coming? With the air. So from the Arabian desert, that air brings this much amount of soil to the ocean. And sometimes when it is in the mid summer, and so this soil in uh, I will say transport increases. And I remember when I was in Goa, I used to see that many times of the year, whenever it is very dry and wind is blowing from the west, that time for 3-4 days even you won't be able to see the sun, because so much of dust is coming from Arabian deserts that it used to cover. Okay, so that much amount of nutrient pool is there in the Arabian Sea, and that is why Arabian Sea is the most productive ocean among all the oceans. So these are really interesting things to know. Now whenever there is too much of nutrient, that actually harms, because then if too much of nutrients are there, then too much of chlorophyll increase is there, and that ultimately reduces the oxygen content and creates the eutrophication. So wherever there is a low nutrient, that is oligotrophic condition, and wherever there is high nutrient, that is eutrophication condition is generated. So what happens is, you might have heard about the Benguela. So that is south of Africa. There, that is a very interesting fishing ground because, it is close to the coast and lots of nutrient comes and fishes are in plenty there. So people actually go there for fishing, and that area is known for fishing. But when due to this threat of algal bloom, that is increased productivity, there sometimes this fishing is threatened. So what we can do is we can monitor the areas. So if you can see the right hand side picture, you will see that we can monitor these areas with the help of satellite imagery. So we can use Sentinel-3 ocean and land color instrument. So using that, we can always monitor the areas, how much is the amount of eutrophication and what is the condition, how severe it is. So actually this can capture the signatures of the biochemicals that affect the algal bloom, so we can know about the situation. So I will not go into very detail of this, but we have to know that we can use the adapted version of the OC4-ME blue-green band ratio when there is a low biomass area. That means not much of production is there, but when there is a high biomass area, then we can use near infrared band. I'm sorry. Okay, so I will not go into much detail of this. Let us come to the oil spill. So oil spill is another disaster in the ocean. So and I must say that this is man-made disaster, because otherwise normally oil is not spilled into the ocean without human intervention. So oil spill can be of different magnitude. Sometimes it could be very less, sometimes it is huge. So you might remember that when there was a fight between Saddam and Bush, then there was a huge disaster because due to that pipeline blast and all, then so much of birds, so much of fishes, everything died because of that. So that is how it is, really really very sad conditions. And we human beings should understand that ultimately, because of our purposes, we are degrading the environment so much, we are creating trouble for so many animals and birds for our purposes. So we should be careful about that. So whenever there is a pipeline break, there is an oil ship sink, and when some drilling operation go wrong, so that itself will induce the oil into the water. So definitely it creates a pollution, water pollution. But then whenever there is a pollution, we have to understand that it is not only difficult for them to live, it is also difficult for us, because we are creating unsafe seafood, which ultimately we'll be consuming and will die, or will be in a severe health consequences. So basically two types of problems arises when there is a oil spill. So first is fouling, second is oil toxicity. So toxicity, you all know that whenever oil is induced mixed with the water, then definitely that water quality is degraded, and all types of toxic things will be mixed with the water. Fouling thing means whenever that oil coat will be there on all the animals or fishes or everything, so that is fouling. Normally in ocean, carbonate fouling is seen. So if a ship is standing, then you will see lots of carbonates are sticking to it. Or if you go to the ports or harbors, there also you will see lots of things are sticking to it. So that is what known as fouling. But here it is oil fouling, because the oil will be sticking on the entire body of all the animals, oceanic animals. So we actually do the change detection with the help of satellite imageries, and change detection from what it was earlier and what it is now. That change itself will tell about the amount of oil spill and the extent, and then size and shape, and how over the time these changes are occurring or where that oil is moving. So we, with the help of algorithm, we can mention that where ultimately this oil will go. So these are the things we can know. So basically we use, spaceborne synthetic aperture radar systems, that is known as SAR. So a combination of GIS and SAR is used for the solution of the problem. So here in this photograph you can see that this light color area, light blue color, is the oil spill, and outside it is the normal ocean water. So in SAR, the facility is that it can give you data under the poor weather condition as well. So it can distinguish the normal sea surface and the oil spill, and we can get the data. And here also similarly you can see oil, but it is here it is used like optical satellite data. There you can make the differences where the oil spill is. So the dark black color is the oil spill. Here also similarly the red color thing is the oil spill, and rest is the normal ocean. So that would be my submission for today. Thank you so much for giving me this opportunity, and I would like to congratulate Mahe for organizing this wonderful training program that is going on for 3 days. And I'm sure all the participants must have benefited a lot from this training program. Thank you and
Thank you.
congratulations.
Thank you, ma'am, for joining us. Okay, after a great presentation, I think we'll go on to our next presentation by Ms. Fatima Amin, who will be speaking on AI in disaster management and risk management. So it is an honor to introduce Ms. Fatima Amin. She is presently a young professional working at National Institute of Disaster Management, Ministry of Home Affairs, New Delhi. She has done Masters in Disaster Management from University of Kashmir, Srinagar, and Jammu and Kashmir. She is working on different papers and participated in national and international training webinar and conferences. She is experienced professional, skilled in emergency management, public speaking, cyber law, PowerPoint, and leadership. It's an honor to have you here, ma'am. I would like to transfer the stage to you.
The introduction every second time, so because people know us, so it's okay. No need for introduction.
That's okay. We have new faces who join us, so it's interesting to know them.
Thank you so much.
Ma'am, we can't hear you. You're not actually audible.
Hello,
Uh,
am I audible?
yes, now you're audible.
Thank you so much for inviting me. So yes, I guess we are over time, so I'll just share my presentation. Just let me know if it's working or not.
Sure, ma'am, sure.
Okay.
Conclusion. No, ma'am, we have that much time, ma'am. We can. Ma'am, you're not audible again, ma'am. You're not audible again. We can see you talking, but your voice is not audible.
Now,
Yeah, coming.
Yes, ma'am. Better. Oh, ma'am, lost you again.
just a minute.
Yeah, sure, ma'am.
Is this okay now? Am I audible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. I think it's the angle of the mic in your laptop. This one, the screen. So that
Yeah,
angle
actually,
matters.
today we are working from home, so it's quite difficult for us.
Oh, now it's crystal
So you
clear.
have to switch
Yes.
off video.
Sharing the whole
You can switch it up later. Yes, ma'am.
coming now.
Yes, ma'am. Clear.
Okay. So yes, I'm really sorry for this small interruption.
No,
So
not at all,
I'll
ma'am.
I'm not just wasting my time, just going to the topic that what's the role of artificial intelligence in disaster management. As everyone is knowing that the artificial intelligence is can greatly help us in emergency and in disaster management. If we see about the efforts, it's not only whenever the artificial intelligence comes in our mind, we usually the only thing comes to in our mind is the America is only using the artificial intelligence, but no, that's not true. The rest of world is also using or can use artificial intelligence in disaster management. So if you know about the drones, the robots, or sensors, and that provide intelligence and accurate information concerning landscape and the damage to the building, or with the help of artificial intelligence, we're able to rescue workers to understand the, if we have to see look at the topography of or the landscape and the extent of damage to a building. So with the help of artificial intelligence, we can do that. Going about to the introduction, so natural disasters are damaging of the physical events caused by natural disasters, natural hazards. So usually the perfect word for we can't say disasters. It's like we used to say. It's best to say the hazards about that. So this situation is exacerbated certain regions for certain population, and it's expected to worsen. So the main focus of artificial intelligence is and how is it is going to impact us, and with the help of artificial intelligence, how or what kind of potential artificial intelligence is having to improve our understanding of natural hazards, or our ability to detect events, to forecast events, or the our ability to communicate effectively, or all the information, like how natural hazards have created a catastrophic damage and its significant economic loss. And AI, if we have to see AI in disaster management, it's in six categories. It's like you have to give the supervised models, the unsupervised model, deep learning, reinforced learning, deep reinforcement learning, as well as the optimization. Okay, it's not moving. I'm not able to.
Yes, I'm still on the introduction
Yeah,
slide.
I'm still on the first slide.
If it's okay, ma'am, you don't need to project your whole screen, and meaning in the sense like, oh, you can keep it open in
Oh,
PPT only. Don't need to full screen it. Again, we lost your voice.
I'm not doing anything. I'm not doing anything. It's the default.
Yes,
I know what's happening. And I am I don't know who to blame, either my desktop or internet. No,
network
internet is working
issues.
perfect. No,
Okay,
it's perfect. I'll try to share my whole screen, and after that I'll see that what happens.
sure.
Yeah. No, when I try to share the whole screen, it's like it comes like this, and is this
This much
video?
is okay. Yeah,
Yeah.
this is okay, ma'am. It's
So,
good enough.
giving the technical definition of artificial intelligence, if we give the technical aspect of what artificial intelligence is, and it's actually defining the technical. It refers to the ability of machines to perform cognitive tasks, like you do the thinking, you do the perceiving, learning, problem solving, and decision making. And it's kind of the computational intelligence is a branch of artificial intelligence that refers to the ability of computers to learn a specific task from data or experimental observation, even though it's commonly considered as a synonym of soft computing. So artificial elegancy means artificial devices having intelligence. That means man-made devices which can acquire knowledge or understand knowledge or apply knowledge. The giving the who actually coined the word, it was John McCarthy. He coined the word artificial intelligence and defined it as the science and engineering of making intelligence machines. So, 151% economic losses is due to the environment-related losses. And artificial intelligence has opportunity for the environmental also. That is how artificial intelligence is helping in us in climate change, or we talk about the biodiversity and climate change, in how clean air and the weather and disaster resilience. The Talking about the applications of artificial intelligence, it's like we can predict and forecast early. It's used for early warning system and resilient infrastructure, resilient planning. See, if I have to give the example of prediction and forecasting, if or of early warning system, we can use early warning system in case of if I have to give example of, I can give example of fires or wildfires or floods. In case of wildfires, it can do it just usually gives us the right time data, what kind of animals that are present over there, or in addition to in a wildlife there are already some cameras are present over there or sensors are present there, but with the help of artificial intelligence, it's like the we can see the rapid adaptation for fire prevention or detection, or we can say the suppression of fire can be done by that. And talking about the floods, the critical mapping can be done for the floods, for the quantification or the reduction of uncertainties. Like we can do the hybrid modeling for and combining process-based modeling for machine learning, or advanced real-time time data or assumption of automatic updation, or in when we are having the data about the floods, we may be we know that what kind of sorry, yeah. So we know that artificial with the help of artificial intelligence, we may be knowing that how floods is going to impact us, or what kind of rainfall data we are having, the right time of the rainfall actually that occurred at that time, and what is the outcome of water that's coming from a particular river, and what will be outcome of that. So yeah, artificial intelligence for disaster resilience is that you can see the examples over there, that how artificial is helping us in disaster resilience is that you can improve the disaster resilience efforts, like you can identify damages and rebuilding, and after a disasters can take months of manual efforts, or leaving affected people vulnerable for a long time. Artificial intelligence can assess damage and help workers delivery aid much faster, improving recovery and shortening the time that affected people stay out resources. The first picture is showing that the predicting and classifying images is done, like with the help of artificial intelligence you can know about how what kind what is this building damaged, is this building not damaged, and if we are having the minor damage in this building and a major in this type of building, and the last one is as this, yeah, the whole building is destroyed. So that can be done. Or we can just geotagging the damage of relief workers. These are the relief workers that are present in that time, or the planning the optimal delivery routes for the rescue officers, or estimating the fund requirement that yeah, this kind of area is affected by disaster, so we just need that kind of fund in a particular area. Now coming to the components of AI that is used in by disaster management, that is we use satellite data for the real-time data. We do the crowdsourcing. We use sensors, mobile GPS. Everyone can do that, and simulation. We can use the combination of variants or aerials. These are kind of components we use in disaster management, and everyone is like aware of how we can use it. Okay, not about the other things, but we know about the GPS, and with the help of GPS you can send the location to the if you are stuck in a place where we are not able to assess you. So with the help of GPS you can give us the accurate location, so the rescuers can help us to take out of that place. The question is, why do we need a disaster management, like a need of AI in disaster management? It was a report in 2018 UN report that India ranked fourth in the that is worst hit by the disasters, including the five, that is US, China, Japan, and Puerto Rico. So globally, economic losses due to disasters between, if we can see, from 1998 to 2017, it's 2.9. And 1.3 billion people lost their lives from 1997 to 2017. So as I was discussing, that we are 151% economic losses increase in last 20 years. That is due to the, either we can say the climate change or disasters. India lost 80 billion to natural disasters over the past 10. 91% disasters out of 7 to 55 disasters were related to climate in last 20 years. This is the application of artificial intelligence in disaster management. See, you can and how the block is connected with the application. The artificial intelligence method is connected related to application areas, and in what phases you can use that in mitigation phase and preparedness, response, and recovery phase. If you have to and do the linear regression, so it's connected to n number of application areas, like you can do the forecast, hazard, and assess risk. If you have to do evaluate possible impacts due to hazards, you can do with the help of artificial learning methods. You can assess vulnerability with the help of artificial intelligence and early warning system, as I was discussing, and you can do the real-time disaster prediction and detection, the training systems, the disaster evaluation, event mapping of that particular area. You can do the damage assessment. See, if I have to give the with the help of artificial intelligence, I have to give I have to locate the particular area. So I will do the mapping, I will do the evaluation, I will do the assessment vulnerability, and that can be done by me. And that is only if I am provided the devices, if I am provided the systems that we use in artificial intelligence. We can use drones, we can use robots, although it's very costly, but with the help of these systems, like with the help of artificial intelligence, we are able to lose the impact of disaster, or we can prevent, the only thing that should matter for us is the safety of people, and we should prevent loss of lives. This is the main point. So we can do with the help of artificial intelligence. And moreover, if we go to the response phase of disaster management, it can do the damage assessment, and disaster rescue and relief resource allocation, disaster information system, and in the recovery period, we do the assess impact, that how much the disaster were having impact. We do the we see in 2009 how much 2019 how much this flood has caused losses, in with the help of mapping, or with the help of that data we are provided with the help of non-linear regression or logistic regression. We can say that we can see, yes, what kind of data we were having in last year, and we can see track recovery about that particular hazard, and we can evaluate loss and repair cost in disaster management. So yes, coming to the conclusion, it was like sorry, just give me a minute. Yeah, artificial intelligence is just to save lives when disaster occur. Leveraging artificial intelligence has numerous potential, using robots, sensors, or drones can help first responders to rescue workers quickly assess the situation, as well as to extend the damage caused, to come up with a sustainable action plan or saving trapped victims. And giving the broad, if I have to give the broad outcome of that this particular thing, like we have to bringing disaster science together with machine learning. One quantifies risk from catastrophic events. Second is empowering leaders to measure, mitigate, and monitorize risk like never before, and enabling resilience from climate change driven disasters. So more important is human life is in danger due to human activities or natural disasters. So disaster is a disaster of one type or another type, which affects human life in terms of life and wealth. Like 6,500 people died in 2017 in Asian content due to 200 disasters, and also $1 billion economic loss is we are saving, and we can't avoid them until we live on the lap of nature. We can only minimize the loss of life and economic losses by using the scientific proper plan with the help of computer information technology and artificial intelligence, and most all private and government agencies like IMD, NRSA, the Central Commission, Water Commission, etc. We can use internet, the geographical information system, remote sensing. With the help of remote sensing, since I guess in previous we were having a previous training, and we were discussing the role of GIS and remote sensing. It's because of remote sensing you're able to go to the places that you're not like physically can't go to that places. We are having trans boundary disasters. So with the help of remote sensing, you may be knowing if a flood may occur in some in our neighboring country. So that flood is having impact. If example, if Nepal is having earthquake, so we may feel tremors and we may face the loss. And with the help of remote sensing, we just don't have to go. That is Nepal is okay, but what if a kind of disaster happened in Pakistan? So it will not be we will be not able to go that place because of some conflicts are there. So with the help of remote sensing or with the help of artificial intelligence, we just can collect the data. What if someone is working on transboundary disaster? So with the help of artificial intelligence, you just don't have to go there. With the help of internet, you can know the actual what was the actual reason behind the disaster. You can know the area that has been affected with them, like the component of information of communication technology in disaster management process. It's not enough to use artificial information communication technology only in disaster management process, because present and future eras of engineering is artificial intelligence. So it's necessary to use artificial intelligence in disaster management to minimize the loss of life and also rescue operation time by using robotics, drones, sensors, etc. And if I guess I like this topic very much. So since I was not having that much of data available on artificial intelligence, as well as people are working on it, but UN, we were having a collaboration with United Nations environmental program. So they are having some good kind of work on artificial intelligence. If someone is interested, you can visit to their website. They are having good things on artificial intelligence. So that will be all from my end. I know I was very quick in sharing this.
Thank you, Amber. Thank you, ma'am, for your quick presentation. Okay, thank you. It's an honor for having you here, ma'am. Have a great day.
Thank you so much, sir. Thank you.
Thank you. Okay, now we come to our last presentation of the day and last session. That is by Dr. Gopal Verma, who will be speaking on Global Assessment Report and Overview. So it is an honor to introduce her. Dr. Gopal Verma is an expert in atmospheric chemistry and climate resilience. She has done her PhD in mitigation of indoor carbonaceous aerosols in rural areas from Jawaharlal Nehru University. She has been conferred with the NISA Junior Scientist of the Year Award in 2018. She is the alumni of prestigious European research courses of atmosphere from Grenoble, France. It's an honor to have you here, ma'am. I would like to invite you to start the session. Yes. Media presenter.
Thank you so
Yes.
much, Mr. Rakshit, for inviting me to this training program. And we are meeting quite often, so it's more you're like family, and NIDM's family.
Yes, ma'am.
So, thank you once again for inviting me. So, please confirm if my presentation is visible.
Yes, ma'am, visible. Yes, ma'am. Full screen is also.
All right. So, since we are talking about disaster management and risk assessment in this training program, so I thought of taking everybody's attention towards what currently the world is talking about. So, I will be going through a very quick overview of GAR, that is the Global Assessment Report for Disaster Risk Reduction, that UNDRR prepares. So, in 2021, they have prepared a special report on drought. So their 2021 global assessment report has completely been dedicated to drought specifically. So let's have a look at this report, in a very brief. So we all know that disaster risk affects everyone, but not everyone equally. And here, with the help of this graph, you can see the extreme weather events. In past 20 years, they are occurring more frequently, and they are occurring with more and more intensity. right? And 70% of major disaster events are extreme weather events like flood, storm, drought, and so on. So there is no part of the world that has not been touched by these kind of disasters. And who has to bear the brunt of these disasters, the impact of these disasters? The vulnerable, resource poor countries, developing countries, right? So, United Nations Office for Disaster Risk Reduction is coming up with this kind of reports, global assessment reports, in once in every 2 years, and this is the office mainly dedicated for disaster risk reduction. And as I already said, this year's report is entirely been dedicated to droughts. So I will be quickly taking you to this report. So first, in this report, they have tried to define what actually drought is, because drought is that kind of a phenomena, because it's kind of that kind of hazard that you may be witnessing a drought and you might not know, right? The drought has started to happen, but you can never understand the transition, right? And in the similar way, it is very difficult to understand the end of drought, how it is ending. So first of all, in this report, they have tried to very clearly define what a drought is, right? Then they have made various warming scenarios, that the warming levels that our world might attain, and in those scenarios, how the drought severity will, propagate to the entire world. So this they have tried to do, and they have tried to propose a framework, a policy framework, that how every country can take up this has problem of hazard, and how they can prepare for the mitigation part. So here with this diagram, we can see how a drought propagates through the hydrological cycle. So there are various drought stages we can see here. So first is the meteorological drought. So when drought enters this stage, what starts happening? There is a deficiency in precipitation, amount starts to decrease, intensity decreases, its timing also lessens, right? So we might take it like, okay, once in a while it is okay that precipitation is less or something like that. So that's how we may not be able to understand that we may be entering the hazard of drought, right? So precipitation deficiency may be there. Then the infiltration, runoff, deep percolation, groundwater recharge may start getting reduced. Then on in terms of climate change, what may start to happen? High temperatures, strong winds, low relative humidity, more sunshine, less cloud cover. So and when increasing evaporation and transpiration starts to happen, then it's very clear that we are in meteorological drought stage. Then even when it becomes even more severe, then we are entering soil moisture drought stage, right? It is also called agricultural or ecological drought stage. In this stage, what starts to happen? The soil water deficiency starts to happen. So there is more stress. Look, there is more plant water stress. There is reduced biomass yield. And last and the most severe drought stage is hydrological drought. And in this, there is reduced stream flow and inflow to reservoirs, lakes, and ponds. Groundwater levels are low. Wetlands are reduced. Right, so these are the various drought stages, and these are various indicators that are there to identify that we have reached this drought stage. So several indicators are being used to consider the drought propagation through the hydrological cycles, and when we monitor these indicators, so we can understand their impact of drought on various economic sectors as well as on the environment. So how we detect a drought event? First of all, that is the question. So when one or several indicators they fall below a given threshold for a defined period, then that is the point that we can recognize that, okay, we are entering the drought stage. We are entering the drought, and this threshold is not same for all the years. It is variable. It depends on the year and the indicators that are being monitored. And as I already said, the end of drought, to identify the end of drought is even more complex, because we will be seeing a graph. So because the return of indicators above the threshold, right, it may happen, and it may be used to determine that, okay, the end of drought is here, because when the indicator has again returned to its threshold value, that implies that the water resources have started to replenish again, right? But what may happen, that these indicators, like different indicators, may return to normal in a staggered process, right? So to define, to identify, to detect that a drought has completely, and how we can say, when all the indicators have returned to their normal threshold value, or the long term average, we'll see, and that will indicate a complete restoration or normal conditions, right? So here you can see with this with this graph, you can see, so here is the indicator, or whatever indicator that we are checking. So this is the long term average of that particular indicator for all the past years, and this is the threshold value of that indicator for that particular year, right? And this is what that year is currently witnessing. So when the actual value starts going down the threshold value, that's how where we can detect the onset, the start of a drought period. And when it reaches the peak, here we can see that this is the most severe point of the drought. And when then again indicator starts to move towards the threshold value and even the long term average value, at that point we can say that, okay, now the drought has come to an end. So this is how we can identify the onset and cessation of a drought. So here this report has talked about 4 different scenarios in which the world can witness the different level of warming levels. So 1.5 degrees Celsius, 2 degrees Celsius, 3 degrees Celsius, and 4 degrees Celsius. So when the world is witnessing warming of this kind at these levels, so they have tried to identify, like entire, what will be the impact, what will be the severity of drought all around the globe, as well as in different continents, right? So all across the globe, in the highest warming scenario, that is 4 degrees Celsius, so that is the most severe drought scenarios which are there for the world, as well as for the continents, for the countries of America. You can see here for South America, Africa, even more severe case, and for Europe as well. And similarly, for 3 degrees Celsius warming level scenarios, the drought severity is going to increase exponentially. We can see here, for especially for these few continents, these few um, uh, countries, right? So now the report has tried to identify a few impacts, and so the drought may have direct or indirect exposure, and so the direct and indirect impacts, right? So directly it impacts on societal level, welfare changes, crop damage, damage to the habitat, and indirectly the indirect or cascading impacts of droughts are disease and poverty, business interruption, and loss of biodiversity. Because you can see that farming, water supply, groundwater, these all are so largely interconnected to all other sectors of a society. So one sector is affected, and the all other sectors are similarly affected. So that's why the impacts are far-fetched. So this is the drought vulnerability with a focus on agricultural systems. So we can see that India is also in a high drought vulnerability zone, and majority of Africa is there in the high drought vulnerability zone. So, so this report has tried to identify these three pillars of how we can manage the droughts in an integrated manner, and these three pillars are preparedness, mitigation, and response, vulnerability and impact assessment, and monitoring and early warning. So they have tried to, they have given these 10 steps for the drought policy and preparedness process, and which is not linear in nature, which is in fact circular in nature, we'll see. So first of all, appoint a National Drought Management Policy Commission. Then second step is very clearly define the goals and objectives of that policy. Then what stakeholders are there, let them participate. So define and resolve the conflicts between key water use sectors. Then next step is inventory data and financial sources. So at this stage, they identify the groups at risk, the groups that are most vulnerable to this problem, the drought. Then write the key tenets of the National Drought Management Policy, right? Following the three-pillar approach that we just saw. Then at the sixth step, we identify the research needs and fill institutional gaps. So here, the need for more research institutions, more research on this topic, more trend analysis, more future projections. Here we can see at this, we can do at this step. Next step is integrate science and policy aspects of drought management. So how science, technology, and innovation can contribute in drought management here. So at this step, we have to see that. Next step is publicizing the policy and preparedness plan. So obviously the plan is ready, but it is incomplete unless the people are aware about this policy that that is there for the drought management. So building a public awareness and consensus, then developing education programs for all age and stakeholder groups, and finally evaluating and revise policy and supporting plans. And if it needs any kind of evaluation revision, and so again it goes to the first step. So in this way, this is circular in nature, right? And in this way, the policy will keep getting renewed with the newer challenges and problems. So this is a very good framework that has been prepared by this report. So I would like to end my presentation with very correct words that Antonio Guterres has mentioned, that in today's time, global challenges are more and more integrated and the responses are more and more fragmented. So if this is not reversed, it is a recipe for disaster. So that's all from my side. Thank you so much.
Thank you, ma'am, for your presentation. It was really short and fast. Thank you. Okay, we hope to see you more towards the next training programs that we have.
Thank you.
Okay, so with this, we come to an end of our 3-day training program on advanced soft computing techniques and in disaster management and risk assessment by National Institute of Disaster Management and Manipal School of Architecture and Planning, Manipal Academy of Higher Education, Karnataka. I would like to invite Dr. Anup Shukla to propose the vote of thanks. Okay, before that, I would like our beloved director for a few words. Dr. Ramadevi, ma'am. Yes, ma'am. Hi, ma'am.
Hi.
Yes, ma'am. You're audible.
Yeah.
Yes,
Hello. Good evening, everyone. So I'm so sorry. On the first day, I think I was held up in some other meeting, so I could not join. But you guys have been doing a great work, and you're organizing the webinars and the training programs very well. And you're getting very good resource persons. I think I should thank NIDM for sustaining such programs, and it is just going on and on. So we are very proud of this. And EMSA being a part of it and Mahi being a part of it, I think it's a great privilege for us. and I really congratulate the coordinators, Mr. Naga, then Anup, and Rakshit, who's always who's the co-host, and Harshit also, who is always there. And that's what I was telling you, everyone last time also. No, every time the programs are very different, and this time there's soft computing techniques to be used in disaster management. I think they are very. I think they have brought in a lot of difference where. You had some very good speakers speaking about geospatial technologies and the usage of these in the disaster management techniques. And congratulate all the speakers, and I'm proud of all these things which are happening. And also regarding the knowledge updation, I think that is immense. Where hadn't we been in this administration position, no, I think we could have spared more time for all these things. But anyway, it is nice to see the youngsters who are really trying to gear up with all this. And another thing, what we would like to see, an offshoot of this should be somewhere where we can really get into some kind of implementation aspects. Whatever we are seeing now, we are all studying and we are looking at the case studies and some things which have been done. But if we can do something, because see, we are also in the coastal belt, so if we can try to do something in this aspect and make it more realistic, I think we should take it forward, and we should work for it. I think with this, I congratulate everyone, and I'm really thankful for the way it has been held. And we would look forward for more realistic projects as well. And thank you, and have a good weekend, all of you.
Thank you, ma'am. Thank you, ma'am, for your words. So now I would like to cordially invite Dr. Anup Shukla for the vote of thanks.
Yes. Good evening to all. A very warm welcome and namaste to our most honorable chief guest, MD Venkatesh, Professor Dr. Anil Kumar Gupta, Professor Dr. N. Rama Devi Madam, Director MSEP, and my colleague and students. It is my privilege to propose the vote of thanks, and I acknowledge the contributions of those who worked hard to make this training program a success. First of all, I would like to thank to Director Madam, Professor Dr. N. Ramadevi Madam, MSEP, Mahi. You allowed me to speak on this auspicious occasions, and it is a matter of honor for me. On behalf of MSEP Mahi, I extend a warm vote of thanks to our key speaker, Professor Dr. Anil Kumar Gupta, Dr. Amit Kumar, NUIST China, Dr. Manish K. Nema, NIS, Dr. Shrey Pathak, NUIST, and Dr. Judas, NIT Warangal, Dr. Surendra Chandania, Professor Chetan Sharma, Dr. Diwakar Naidu, Dr. Jan Mohammad Wani, JNU New Delhi, Dr. Sweta Vedidas, NIDM, Dr. Upal Verma, NIDM, Harshit Sharma, NIDM, and Ms. Fatima Amin, NIDM, who spared time for his or busiest schedule to grace the occasion. And finally, I would like to take this opportunity to mention our deep sense of appreciation to NIDM team, especially Harshit Sharma, young professional ECDRM, and Ms. Fatima Amin, ECDRM, for their unconditional support, without whom it would not have been possible to organize an online training program successfully during the pandemic. And finally, I also thanks Mr. Naga Venkat Sai and Rakshit Singh Bist for their heavy cooperations in the organizations of this program. Now, I would like to end the vote of thanks. Over to you, Rakshit.
Thank you, Anup sir. I think due to technical difficulties, I couldn't join. I would request everyone to please switch on your video so that we could take a group photo. Oh, okay. We have a news that even Anil sir is joining us. A few words from Anil sir also before we end the meeting. So it's a privilege to have him here during the end of our program, of a 3-day training program. Just a minute or two. Anil sir is also joining us, so we're just waiting for him to join. Thank you all for your patience.
Hello.
Good evening, sir.
Good evening. Good evening. Actually, I was in a different meeting, so it took some time.
No, it's
Then,
okay.
so I'm sorry for that. So
Yeah.
then, so I'm very happy the way it has been designed and it has been conducted. So I was getting all feedback from my team, and they're very happy. Harshit could not join today, so in place of Harshit, Miss Fatima is coordinating, and this program was not organized in such a wonderful way that we are very happy, and we want that how do we make more impact of these programs, because hopefully now this COVID will be over soon, so we can have more effective way and face-to-face program also.
Yes, sir.
But not only training program in short way, but we are also thinking that how we also think of assigning some credits to these kind of courses. Maybe if someone has completed a series of these kind of courses, and then we have a set curriculum, and then we are able to assign him some credit. So we are also planning that if we can at an IDM, we are thinking of having a kind of a credit bank, so that after completion of a certain credit, we can also think of awarding some certificate or diploma or something like that. So that also is our plan. So we'll be discussing with you on this aspect also. Your views also we'll invite and we'll talk, and then joint individuals also will see. But this topic that was chosen here for this program is very, very important, and the kind of lectures that you have included. So those covered not only the conceptual framework, but even the case studies, and then practically showing. Though I know that on the online platform there are a lot of limitations, but then also the speakers tried to adjust their lectures in such a wonderful way.
Yes,
So I could have some insights of lectures. I could not attend all lectures, but the lectures were very, very useful, and I hope the participants liked those lectures and got benefited. So that is very important. Now I would also request the participants that see this training is not actually ending. Training is a continuous process basically. So though this online platform for 3 days now we are closing, and we may have another program for some time after some time, but the training continues or the learning continues. So all of us are learning, in fact, not only not we can say that someone is a resource person, someone is a participant. All are resource persons and all are learners. Basically, we all learn. Every day we learn so many things. And why it is important in disaster management? Because the subject is so vast. No one can say that he's really an expert of everything in disaster management. Such is interdisciplinary, vast subject. It's very important. So the world is changing, and world is moving towards more and more automation, more and more robotics, more and more use of nanotechnology. And the ICT, the IT is basically artificial intelligence is the new world basically. So how we use these kind of techniques, computational techniques, that is very important, because yesterday also I was discussing with some experts, and the issue was that database, and when there's a huge amount of data, so how a huge amount of data, how do we process very prudently so that we arrive at correct decisions? So very important. Very nicely covered by speakers. But still I invite some, if participants have any kind of suggestions, please share with us. They can mail us on WhatsApp or whatever way. On chat box also they can write their suggestions, so we can include those topics in our future programs also. So thank you very much for taking this endeavor, and to the Manipal Institute, all the faculty members, all the authorities, and to Dr. Vashisht and all team. All the members of the team from Manipal Institute, and from NIDM, Mr. Harshit and Fatima. Everyone deserves a big congratulations and thanks. So thank you so much, and very positive team. What I have seen, that all the team members are so positive. That is the beauty. So thank you once again, and congratulations to all the speakers, all the participants. Thank you very much.
Okay, thank you,
Thank
sir.
you, sir.
Namaste, sir.
Thank you, sir, for gracing us with your presence. So we would like everybody to switch on the video. We'll just take one group photo before we end our meetings. Everybody, could you turn on your video just for a minute so that we could take a group photo of everyone who has joined? We'll just give them about another minute so that everybody can switch it on, get ready a little. Okay, thank you all. Thank you all for joining us. Please stay safe. Have a great day and a great weekend ahead. Namaste to all.
Namaste. Thank you.